All right. Testing 1, 2, 3. Hello, world. Can everyone hear me okay? Yes? Yes, okay, wonderful. Well, so nice to see so many faces here around the world. If you haven't already, feel free to say hello to everyone else in the chat and where you're from, perhaps. This is a live filming of CS50P, CS50's new Introduction to Programming with Python class. As you may know from online and our emails, we're filming these live with you as the audience, so it'll be an opportunity to ask and to answer questions along the way. Might make some mistakes along the way, so I hope you'll forgive if we stop or fix things as we go. The final edited versions of these videos will then end up on CS50's website, YouTube, edX, and beyond once they're fine-tuned based on how today goes. For those who are joining us for the first time, just a couple of FYIs. All of today's slides and all of today's source code, the programming code that I'm going to write, can be found at this URL here, if you haven't discovered that already. If you find the chat distracting, something we say each week is that the easiest workaround to do this is to go to your chat window, find the little triangular menu, probably in the top left, and then pop it out, and then just drag and drop it to like the bottom of your screen. And that way you won't constantly see the badges and the pop-ups, but those who do want to converse via chat or ask questions of Carter, my colleague here, can still do so. The Zoom chat tends to be a little noisy. That does not work on mobile, but it will work on laptops and desktops. If you haven't already, this is the website where you can use VS Code or Visual Studio Code in the cloud using CS50's account. Note that sometimes if too many people log in all at once, GitHub doesn't allow us to have that many people coming through at once. So if you get an error message, wait a minute or more and then give it another try. And then we have this tradition, which is now, if you would like to participate in a souvenir photo that we'll post online, go ahead and turn your camera on if it's not yet on. Go ahead and turn your camera off if you don't want a photo of what you look like today to end up on the internet. And we'll go ahead in just a moment. And as some of you are already doing, put on your best smile, your best wave. And my colleague Rung Shin here is going to take as many screenshots as he can, one at a time in Zoom. Hopefully we'll catch you at a good-looking moment. If not, hope you'll forgive there too. Feel free to vary it if you want to change hands or something like that, or put on a funny face. Maybe we'll catch that instead. But what we're taking is a whole bunch of screenshots now, and then using fancy software that Rung Shin wrote, we'll stitch them all together into the illusion of one really big Zoom room instead of screen after screen. All right, we are all good there. Allow us to just take a couple of hellos on camera, make sure all of our audio is working nicely, and to hear from some of you. If Rung Shin, we could put everyone's hand down just for a moment, virtually. All right, and if you'd like to say hello to folks on camera here and a little something about where you are in the world or about yourself, why don't we go ahead and call on just 2 or 3 people before we dive in. Let's see. How about we start with, all the tiles are moving around, Chinmay, if I'm saying that right?
Hello.
Yes, we can hear you.
Hello, David. It's very nice to learn from you.
Oh, well, nice to have you in the class. Welcome. Where in the
I'm
world
from
are you?
India. I'm from India.
Nice. Well, welcome to Harvard virtually today. How about another hand from the group? Rung Shin, if we could call on Harshita next, if I'm saying it right.
Hello, sir. It's glad to learn from you. I'm Harshita Sharma from India.
Nice
I hope I can learn from you.
Yes, nice to meet you as well. I'm guessing it's getting later there, so thank you for staying up with us here. How about one more hello from the group? My colleague Rung Shin is helping pin people on the screens here. Seham, if I'm saying it right?
Hello.
Hello.
Hello, I'm Siham. I'm Palestinian, but I'm now in Hungary. I hope that I learn from you. Thank you.
Oh, well, I do too. Well, nice to meet you as well. So before we dive into today's 2 lectures, we're going to film what's called Lecture 5, which is going to focus on unit tests. Then we'll take like a 10+ minute break. Then we'll resume with Lecture 6, which is going to be focused on file I/O, input and output. If you have no idea what either of those things are, that's good. You're in the right place. So after the first lecture, even though you might hear me saying, that's all, goodbye, we're just going to take a break and then start again, since we're pretending to shoot these separately. Before we do that, though, wanted to introduce a little informally one topic that we didn't touch on last week, which was this. For those of you who were in attendance last week, we ended with this example on the screen here. This was an example of a file called sayings.py that had two functions, hello and goodbye. For those who weren't here, this was just an example of two functions that I started to realize I'm using a lot. I keep writing all these programs that just say hello all the time, and for that matter, that say goodbye now as well. And I realized, wouldn't it be nice last week, where our focus was on libraries, wouldn't it be nice to write my hello function once, write my goodbye function once, and then just reuse that code for project after project after project, as opposed to just copying and pasting or rewriting these things from scratch. So those of you who were here might recall that we used that file in a different code file called say.py. In say.py, we imported the sys library, which gives me access to those things called command line arguments. If you weren't here last week, not a problem. But this was the interesting line. We were able to import a specific function from my sayings.py file using this line of code here, from sayings import hello. And that just gives me access now in say.py to the function called hello in the other file called sayings.py. And it allows me to really invent my own library that I can now use in this program and any future programs as well. And heck, if I put it on the internet, you also could use my hello or my goodbye function. But it's worth knowing that you can create problems for yourself when creating libraries if you don't adhere to best practices. And so let me propose this. Let me first run this program to remind you what it did. If I run python of say.py and then my name, D-A-V-I-D, it just said hello David. And that's the code we're looking at right here. But notice that the function we're calling on line 6, hello, is actually defined in this other file, sayings.py. Now suppose that I realized that I might want my sayings file to be functional unto itself, and I just want to be able to test this file. And so up until now, we've been in the habit of running our own functions by defining arbitrarily, but conventionally, a function called main. And so suppose I just want to try out this function. I might do this, hello, quote unquote, world. And then let me try out the other one, goodbye, quote unquote, world as well. In other words, I'm defining a main function for the sole purpose of like testing these two functions. Now, of course, if I go back to my terminal and run python of sayings.py, enter, nothing happens. And just to rewind to past weeks, why did nothing happen? How can I fix this at the moment? I have a main function now, and I have hello and goodbye. Why did nothing happen on the screen? Any volunteers? Yeah, over to Gurkhan, if I'm saying it right.
Can you hear me?
Yes, we can. What are your thoughts?
Okay. We didn't call main function at the end of the file.
Exactly. We didn't call main. So this is not like C or C++ where main just happens automatically for you. In Python, you have to be more deliberate and actually call the function. So up until now, the habit we've been in is just calling main as the very last line of your file just to guarantee that main is absolutely called, but it's the last thing that's called so that you're defining first so that the functions all exist. And then at the very end, you kick off the execution of the program by actually calling main. So this is now correct for sayings.py. And if I run python of sayings.py again, notice that we see my two test outputs, hello world and goodbye world. So all is working well. But notice this. I've created a side effect for myself. If I leave those tests in that file, that is, I leave my main function in there, notice what happens if I go over to say.py now, which is a completely different program that is importing one function. I'm not importing main. I'm not importing goodbye. I'm only using hello just like before. So let me do, just like before this, python of say.py and then David, my name in the command line argument. I should see, like before, hello, comma, David. But let me hit enter. I'm seeing hello world, goodbye world, and then hello David. And this is a really bad feature of a library if I'm just trying to use this function hello and it's presuming to output hello world, goodbye world, and then what I actually care about. So let me ask the group again, why now is this happening? Just to be clear, why am I seeing 3 lines of output from say.py even though I only called hello once? Dev, your thoughts?
Yeah, I think it's because you called a main within sayings.py.
Yeah, it's of course because I called main in sayings.py, and it turns out when you import a function or anything else from a file, the entire file is interpreted by Python, top to bottom, left to right. So if you've got a line like my last one in sayings.py, main, open paren, close paren, it's going to call main no matter what, even if you didn't run sayings.py at the command line itself. So I could, of course, just undo everything I did. I could go back to sayings.py, and I could just delete this last line. I could even delete main, but then I've lost my test functions. And maybe longer term, it's just convenient to be able to test my hello and goodbye functions. So that too doesn't feel like an ideal solution. So the right way of doing this, the typical way of doing this, is to actually introduce a fairly funny symbol here. So it turns out that built into Python is this special variable, underscore underscore name underscore underscore. And that variable is automatically set by Python whenever you run a program. Specifically, it's set to a specific value if you have run a program directly. So what do I mean by this? Let me go ahead and change sayings.py to not just blindly call main anymore. Let me do this, albeit cryptically. If underscore underscore name underscore underscore, and there's indeed two underscores, even though the font is making them look close together, if that variable equals quote unquote underscore underscore main underscore underscore quote, and now let me add my colon and indent main as part of this conditional, this is now saying to Python, only call the main function if the name of this file is itself main. And honestly, this is not at all clear when just looking at the code how this works, but let me show you by demonstration. Let me go back to my terminal window and run Python of sayings.py, which in the past printed hello world, goodbye world, and that's it, because that's all that's in this file. But notice I'm conditionally calling main at the bottom of this file, but let's see if the condition works out to be true. Let me hit enter in my terminal, and it works. Hello world, goodbye world now works. But now let me change tabs. Let me go back to say.py, and notice that I've made no changes to this. I'm still importing from sayings the hello function, which is still going to involve Python reading the entirety of sayings.py, top to bottom, left to right, and doing what it says. But because sayings.py now has this conditional saying only execute main if the name of the file is main, this import is going to behave differently. When I now go back to my terminal and run not Python of sayings.py, but Python of say.py, this shorter program here, it is now using hello by importing it, not by running the sayings.py file directly. I'm running say.py instead. So when I hit enter now, you'll see that, damn it. So now nothing happened. Let me fix that. That's user error, not curricular error. Now, Python of say.py and my name, like before, and let me hit enter, and now we only see hello David. So in short, the right way moving forward to define a main function is just as we've done up here. If you want to have a main function, that's fine, do it. But only call it conditionally, because you want to make sure that main is only called when you run the file directly, Python of sayings.py. You don't want main to be called when you import this file or any functions therefrom. So that's what this very cryptic looking condition is doing. And it's indeed deliberate that it's underscore underscore main underscore underscore. This is just automatically done for you by Python, independent of your having defined the main function. All right, that's a lot. Let me pause and see if there's any questions. Any questions here? Yeah, how about over to Nathan from you?
Yeah. Is there any reason why there are two underscores in front and before? Is there a specific reason why they're there, or is that just a way of defining them?
It's a convention. So it's that way just because. That's what the authors of Python decided. In many languages, though, it is conventional for the authors of the language to reserve, sort of unofficially, any variable that starts with underscore underscore is belonging to the language itself. Like you, the programmer, should not write functions that start with underscore underscore. Single underscore is OK. Double underscore is bad. It's a little weird that there's underscores at the end of it too, but that's just what the Python community has done. It's a visual clue that this isn't your special thing. It's someone else's design. A good question. Other questions on this use of name and main? Anish, if I'm saying it right?
Hi, David. David, I have one query. Like if we'll run sayings.py,
Hmm.
then it will output us hello world, goodbye world, right?
Yes, correct.
So does that mean that by default, if we run a particular file, even though we have set that underscore underscore name to be underscore underscore main, Python assumes that the file name is still underscore underscore main underscore underscore.
When you run it directly, this all happens
Right.
automatically for you. But when you import it, underscore underscore name is not set to main. It's not. And
Oh,
for demonstration's sake, let me try this. Let me do this. Instead of doing all of this, let me go into sayings.py and do print underscore underscore name underscore underscore. And now let me do this. Let me run Python of sayings.py, enter, and you'll see that the name of this file, by convention, even though we've named it something else, is underscore underscore main. If I now do this, Python of say.py, which imports from this file, we see this. We see that the name of the file is not underscore underscore main because it hasn't been run from the command line directly. It's instead the name of the file itself. And this is useful to be clear because recall the libraries we did talk about last week. If you were here, we looked at the random library, the statistics library, and there's so many others as well. Cowsed library. It would be really bad, really obnoxious if any of those libraries had their own main function, and just because you import one of those libraries, boom, you're seeing someone else's output. So this is a solution to that problem, to avoid other people's libraries or your own libraries from having these side effects. How about one more question before we reset and dive into today's unit tests? Yashvi, if I'm saying it right?
It was just a curious question, David. What if we run, instead of your name, we write main in say.py? Would it implement hello world and goodbye world? Or would it print hello main and goodbye main?
Hello me. So instead of, let me go back to the file. So instead of world, plugging in something else here? Oh, sorry. There we go.
No, in say.py.
OK.
When you entered your name, what if we entered there instead of David main?
If we said instead of David main instead?
Yes.
Oh, I mean, we could. If I'm hearing you correctly, are you proposing that I do this?
Yeah.
OK, we can do that. Let me do that. So Python of say.py, and you'll let me fix the other file. Let me undo my change to sayings.py so I have the if condition that we've been promoting here. Let me now rerun this correctly. Enter. Oops, here we go. I still have to provide a command line argument so that the length of argv is 2. And you now see hello main. So yes, you can see that as well. It's a coincidence, though, that we're talking about names like my human name, but the name of this variable is also underscore underscore name. It's cryptic. This is not the best, clearest design, but this is the way it is. So moving forward, anytime you write a main function and call a main function, don't call it blindly like we have been previously, because that's going to create new problems for us. Always wrap it in this conditional using literally this syntax. You don't change name and you don't change underscore underscore main. Those are just always that way, just because, so to speak. All right, give me just a moment to close these files, and in just a minute or so, we'll resume with today's Lecture 5 on unit tests. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on unit tests. Up until now, we've been writing a lot of code, and you might have been testing your code by running your program and passing in some sample inputs, and running it again and passing in some sample inputs, or you might have been waiting for us to test your code instead. But it's actually much better practice to get into the habit sooner rather than later of testing your own code using code of your own. In fact, whether you're writing a personal project or working in industry, it's very common nowadays to not only write code to solve the problems that you want to solve, but also to write a little extra code to test the code that you wrote. And that's what we're going to focus on today, writing our own tests so as to be all the more confident, all the more certain that the problems we have been trying to solve are in fact solved correctly. So let's rewind a few weeks now to a program we wrote a while back, namely to calculate numbers. And specifically, we left off with this calculator on trying to compute the power of a number, like x squared, or where x might be 2 or 3 or some other number as well. Well, let me go ahead and resurrect that file by going into my terminal window here and running again code of calculator.py. And let me go ahead and pick up where we left off way back when by defining a main function here. And then in my main function, I did something like this. I said x equals int of input, and I asked the user, what's x, question mark. And then I immediately went ahead and printed out something like x squared is, and then I passed in as a second argument to print the result of calling a function called square, passing in that value x. Now, of course, I haven't yet implemented the square function, so let's define that as well. Let me go down a couple of lines and define square. And it takes an argument, recall, a parameter that at the time I called n for number. So I'll do that again, though I could technically choose any name for this variable. And I recall did this. I returned n times n. And there were multiple ways to do this. The squaring a number is multiplying it by itself. So I could also use other syntax here, but this is what we ultimately settled on. And then recall that I ultimately called main in order to kick off the process of running this program. So just as a test manually, let me go ahead and run Python of calculator.py and hit enter. What's x? Let's start with 2. All right, x squared is 4. I think that's correct. So let's run it again just for good measure. Python of calculator.py. Let's type in 3 for x this time. X squared is 9. And I think that's correct. And I might be feeling pretty good at this point, and I go off and submit my code to a course, or I post it on the internet for others to use. But I haven't really methodically tested this code. And it's not necessarily the case that it works entirely. In fact, I haven't really considered a number of corner cases. I went with some pretty obvious numbers like 2 and 3. But what about 0? What about negative numbers? What about any number of other infinite numbers? Well, we're not going to test an infinite number of inputs to this because the program would never halt. But we should test some representative inputs ultimately. But before we do that, let's get into the habit of making sure that main isn't always called. Let's adopt this habit again of doing if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore. Only then should we execute main. And I'm doing this now proactively because I want to make sure that when I import my square function, perhaps from another library, from another file, treating it as though it's a library, I want to make sure that main is not just automatically called itself. Now, what do I want to do from here now that I've modified this program as follows? Well, let's go ahead and write a completely different program whose sole purpose in life is to now test this program. So I've got my actual calculator in calculator.py. I've readied myself to call main conditionally so that I can safely import one or more things from this file in another file. Well, what should that other file be? Well, by convention, I'm going to create a file that's called test underscore. And then because the thing I'm testing is this calculator itself, let's call this file test calculator.py. That's going to give me a new tab in which I can write a brand new program whose purpose in life is now specifically to test that program, but really that program's specific functionality. Built into that program is the square function. Let's focus on testing that function. All right, so how do I access that function in this program? Well, recall that I can import a function from another file as though it's a library of my own, a so-called module. So I'm going to do this. From calculator, import square. I could go ahead and just import square itself, but then I would have to prefix my use of square, recall, by saying calculator dot everywhere. And it's just a little cleaner to just import the one function. And now let me go ahead and do this. Let me go ahead and define a function called test square. This too is a convention. If you want to test a function called square, your function for testing should be called test underscore square. Or alternatively, you could do square underscore test, but I'll adopt this convention here. Now, what kind of tests can we do? Well, I don't dislike the tests I ran earlier, testing x equals 2 and x equals 3. But every time I want to test my program previously, I would have to do that manually. And that's going to get tedious. It's not going to be easy for someone else to test it. And if I'm actually working in the real world, it would be nice if I could automatically have my program tested again and again by having some automated process run my own code. So let's do that and take the human ultimately out of the equation. So how might I go about testing the square function that I've now imported per line 1? Well, in my test square function, why don't I do this? If the result of calling square of 2 does not equal 4, why don't we go ahead and print an error message? Because I know that in the real world, 2 squared should equal 4. So if square of 2 does not equal 4, there's a bug in my program. There's a bug in my function. I've made a mistake. So let me go ahead and print something like that so I or someone else knows 2 squared was not 4, for instance. So I could print out anything here. What should I maybe next test? Well, let's do more than one test. Let's say if the square of 3 does not equal 3 squared 9, then let's go ahead and print out that 3 squared was not 9. So I haven't done any more testing than I did earlier, but I've baked those two tests, x equals 2 and x equals 3, into my own code here, so I can now run those tests automatically, if you will. Now, it's not enough to just define a function called test square. I actually, if I want to run this function, need to call it somehow. And our convention for doing that is the same as always. In this function here, in this file too, let me define main. And main's sole purpose in life is going to be to test square. And now at the bottom of this file, as before, let me go ahead and adopt my convention of if underscore underscore name underscore underscore equals equals quote unquote underscore underscore main underscore underscore, then go ahead and call main. So a lot of this is just boilerplate. Like we've seen this before, defining a main function and calling a function to kick off some process. Now adding the conditional at the bottom of the file to make sure I'm only conditionally calling main just in case I import anything from this file elsewhere. So let's see. Let's go ahead and test my code now. Let me go ahead and run test calculator with Python and hit enter, and nothing outputs. Nothing outputs, but I think it's OK. I think no output is good because look at my test square function. I'm not printing anything if all seems well. So let's demonstrate as much by going back to my calculator and let me break it. Let me introduce a bug. Maybe I didn't even get it right the first time. Maybe my code originally looked like this. I wasn't thinking. I forgot my squares. And so I thought that the square of a number is n plus n instead of n times n. So a reasonable mistake to make, perhaps arithmetically. Let me now go back to my test calculator, which I'm not going to change, but I am going to rerun it. Python of testcalculator.py. I'm going to cross my fingers here, but for not, I'm going to see immediately that 3 squared was not 9. Now, what is it? Well, let's see. When your tests fail, how can we put our finger on what's wrong? Well, it's a little interesting that I completely broke my square function, and yet only one of these tests is failing. It looks like this test, lines 9 and 10, is fine because I'm not seeing that output. But of course, these two lines, this test is failing because 3 squared is not 9 when I'm using plus. So just to be clear here, why is my function only partially broken? Just to be clear, why am I seeing only one error instead of 2, even though the square function is now mathematically broken? Nikita?
Because 2 plus 2 is 4. No.
Yeah, I mean, it's as simple as that. I just got lucky that 2 plus 2 is the same thing as 2 times 2. So this is one of those corner cases. And this is why it's good to be in the habit of not just testing one thing, but test several and make sure you're covering your bases, so to speak. So I got lucky here, and that explains why I'm seeing only one error, even though the function itself is flawed. But let me propose that there's another way we could do this, because honestly, if I extrapolate from this simple example, running not just 2 tests, but 3 or 4 or 10 or 20 tests, you can imagine that, my God, the code is going to get so much more complicated than the function itself. I mean, already, look, in calculator.py, the function in question is 2 lines long. And yet in test calculator, the code in question is 5 lines long. Like, I've written more code to test my code than I actually wrote original code. So the fewer lines of code we can write when testing code, I think the more likely you and I are to do it, because it's going to be literally a little less work and just fewer opportunities for mistakes. So what's another approach I can take here? Well, it turns out in Python, there is another keyword that we haven't yet used, which is this here, assert. Assert is a keyword in Python and some other languages as well that allow you to do exactly that as in English, to assert that something is true, to sort of boldly claim that something is true. And if it is, nothing's going to happen. No errors are going to appear on the screen. But if you assert something in Python and it is not true, that is, the thing you're asserting, a Boolean expression, is false, you're actually going to see some kind of error on the screen. So let's go ahead and try this new keyword as follows. Let me go back to my code here. And just to make it a little simpler, let me propose that I use this new keyword as follows. Let me simply assert that the square of 2 should equal 4. So I've changed my logic. Instead of checking for not equals, I'm now asserting very loudly that it should equal 4. And then on one additional line, let me do the other test, assert that the square of 3 equals 9. And that's it. No if, no indented print. I'm just going to assert more simply these 2 things that I want to be true. Well, let me go ahead now with calculator.py still broken. I'm still using plus accidentally instead of multiplication. Let me go ahead now and run Python of testcalculator.py. Crossing my fingers as always, but it's not going to go well this time. A whole lot of errors seem to appear on the screen. And if I scroll up here for this traceback, we'll see that the thing that failed was this line here. Assert square of 3 equals 9. Now, unfortunately, when you're using the assert keyword, it's not terribly user-friendly. It shows you the files and the line numbers involved, but it does show you the specific line of code that failed, the assertion that failed, so to speak. It's now kind of up to you and me to infer from this, well, wait a minute, why is the square of 3 not equal to 9? So it's not super user-friendly, but honestly, it was like half as much code for me to write. It's just 2 lines instead of those previous 4. But notice this. Little remnant down here, this was an assertion error. And we have seen errors before. We've seen errors before when we've made other mistakes in our code. And in the past, what was our solution for catching those errors? How do we catch errors that seem to resemble this, even though we've not seen this one before? Tolu?
Try and except.
Yeah, in Python, we can use the try and except keywords to try to do something optimistically, except if something goes wrong, do something else instead. So this is a step forward in that I can at least catch this error, but it's going to be perhaps a step backward in that I'm going to end up writing, I'll admit in advance, a little more code instead. So let me go ahead and try this. Let me go back into my code here, and instead of just asserting blindly, let me go ahead, as Tolu proposed, and try to do this first assertion, except if there is an assertion error, like we saw a moment ago, then go ahead and print out something more user-friendly that explains what actually failed. 2 squared was not 4. And let me go ahead similarly and try to assert that the square of 3 equals 9, except if there's an assertion error there, in which case I'm going to print out more user-friendly, 3 squared was not 9. So I've taken a step forward, but also a step back, because now I have more code, but I have at least introduced assertions and exceptions in a manner consistent with how we've seen in the past. When something goes wrong, you actually see an exception raised. Well, let me go ahead and run this version of the program now instead. Python of testcalculator.py, crossing my fingers. All right. It still failed because I'm seeing output, but we're back to at least user-friendly output. So that's at least progress in some way here. But it's, again, more code than might have been ideal. And in fact, if we continue this further, what if we actually want to add additional test cases here as well? Well, it seems like we might end up writing way more code than would be ideal. For instance, I'm testing 2 and 3 now. I should probably test some negative numbers as well. So why don't I go ahead and add in, for instance, let me go ahead and copy and paste this. Let me try to assert that the square of -2 equals 4, which should be the case mathematically. And if not, let me go ahead and change this to say -2 squared was not 4. And you know what? Let me go ahead and copy paste this again, test another negative number just for good measure. Let's test the square of -3, which should equal 9. But if it doesn't, let's go ahead and say that -3 squared was not 9. And just to think aloud here, what might be another good value to test? I've tried 2, I've tried 3, I've tried -2, I've tried -3. I can't try in infinite numbers, but there's at least something that's a little different in between those values. Let's try 0. 0 is an interesting case too, just in case something might be wrong. And why 0? I'm just going with instincts here, right? Odds are positive numbers are generally going to behave the same. Negative numbers might generally behave the same. 0 might be a little anomalous. There's no science to it necessarily, but rather considering for yourself based on your own experience, like what are the potential corner cases based on the function you're trying to test. I'm trying to test something mathematical, so I want to test representative values. So let me go ahead and paste in one more try except block. Let's assert that the square of 0 should equal 0. And if not, I'll say something explanatory like 0 squared was not 0. Now if I go ahead and run this, Python of testcalculator.py, and hit enter, now I see multiple errors. And this is interesting. It's a bit of a clue because notice that some, but not all of these assertions are failing. The one for 2 squared is apparently OK, as we noted earlier. Recall that 2 squared happens to be 2 plus 2, so that bug doesn't really throw off our test. But it's a good thing we tested for 3. It's a good thing we tested for -2 and -3 because all of those tests caught this error. The 0 test did not notice because 0 squared is, of course, 0, but 0 plus 0 is 0. So we're getting lucky or unlucky there, depending on how you view the glass as half full or half empty here. We, at least by way of having multiple tests, caught this mistake somehow. So it would be nice, though, if we weren't writing so much darn code here, right? Because notice what I've done. I have try, except, try, except. I have all of these assertions. I have a main function. I have this if conditional at the bottom of my file. I mean, honestly, who's going to want to write 31 lines of code now just to test a 2-line function, right? No one's going to write test code like this if we're all writing so much more code to do the actual testing. So people have solved this problem. If you are in the habit of testing your code a lot or wanting to, if I'm in the habit of wanting to test my code a lot, if everyone else in the real world is in this habit of wanting to test their code, why don't we create tools that make it a little easier to do so? And in fact, there is a mechanism for doing this whereby we can use a tool that's popularly called PyTest. So PyTest is a third-party program that you can download and install that will automate the testing of your code so long as you write the tests. But what's nice about this library and others like it is that it adopts some conventions so that you don't have to write as many lines of code yourself manually. They do some of that automatically for you. Now, this is a third-party library. There's other libraries for unit tests, so to speak, that is testing units of your code. Some of them come with Python itself. We're proposing that we look at PyTest today because it's actually a little simpler than the unit testing frameworks that come with Python itself. And what do we mean by unit testing? Unit testing is just a formal way of describing testing individual units of your program. What are those individual units? They're typically functions. So unit tests are typically tests for functions that you have written. Now, what does this mean in practice here? Well, let me go back to my VS Code here, and let me propose that we simplify my test calculator significantly. I'm going to go ahead and delete all of these tests, which were accumulating to like 31 lines of code. And let's see if we can distill the tests to their essence using PyTest. From my same calculator program, let me still import square. So I do still need that line of code so that I can test that specific function. Now I'm going to go ahead and define a function just like I did before as follows. I'm going to define a function called test square, again by convention, test underscore, and the name of the function you want to test, though it doesn't have to be that way. And now I'm going to go ahead and make a few assertions. I'm going to assert that the square of 2 should equal 4. I'm going to assert that the square of 3 should equal 9. I'm going to assert that the square of -2 should equal 4. And I'm going to insert that the square of -3 should equal 9. And lastly, for now, I'm going to assert that the square of 0 should equal 0. So I'm still using the assert keyword, as I introduced earlier. And even though it was a little tedious to type those, I mean, it's only 8 lines of code now, and they're so easy to type. It's not try and except and all of this. Wouldn't it be nice if something else, someone else, handled the try the accept, the printing, all of the standardization of actually running these tests. And that's where, indeed, PyTest comes into play. Per the documentation for PyTest, which can itself be installed with pip install PyTest, which we've used to install other libraries in the past, you can look at the documentation here for all of its formal usage. But fortunately, PyTest is pretty user-friendly as testing frameworks go, and it actually allows us to dive right in by just running PyTest on the code that we've written. So if I go back to VS Code here and look at my testcalculator.py, which, notice, has no main function anymore. It has no conditional. It has no tries. It has no accepts. It has no prints. It just has my few assertions. PyTest and other libraries like it are going to automate the process of running these tests for me and informing me on the screen whether or not any of those tests failed. So let me go ahead and do this. I'm going to go ahead and increase the size of my terminal window for a moment, just so we can see more on the screen. And I'm going to run not Python, as I've been doing. I'm going to run PyTest, which again is this third-party tool for running tests in your code. I'm going to run PyTest of test_calculator. So that same file, I'm going to cross my fingers as always and hit Enter. And we'll see that, something has failed. Now, admittedly, even though I do think you'll find that PyTest is relatively simple to use, its output, at least at first glance, is not necessarily super user-friendly. So what are we seeing here? Well, notice at the very top of my window is the command that I ran after my prompt. Right below that is a single F in red, which means fail. So not very encouraging. I tried really hard here, but fail is my grade on this program. But let's see exactly what happened. Well, if I look at this excerpt here, under failures, you'll see that test square is the function that failed. All right, that makes sense because that's the only one I wrote. And you'll see here somewhat arcane output describing what the error was. So what you're seeing here is the first line of output, equals 4, which is fine. There's no red error message below that, so that one's OK. But this line of code here, assert that square of 3 equals 9, PyTest did not like that assertion because it didn't end up being true. In fact, per the red E at the start of this line, you'll see that I'm effectively trying to assert that 6 equals 9. Now, where did the 6 come from? OK, wait a minute. If my test involves this, notice that where 6 equals square of 3, this is saying that because I've called square, passing in a value of 3, it turns out its return value is 6. And of course, mathematically, 6 does not equal 9. So that's why this is failing. Now, PyTest is not as user-friendly as telling you exactly why the bug is there or how to fix it. This is really just a clue to you what must be wrong. What you're seeing here is a clue that the first test passed because there's no red error below that line of code, but this test failed. Somehow or other, your square function is returning 6 when passed in 3 instead of 9. So at this point, you sort of put your detective hat on, you go back to your actual code, and you think about in calculator.py, how in the world is line 7 of my square function returning 6 instead of 9? And at this point, odds are the light bulb would go off above your head proverbially, and you would see, oh, I'm using addition instead of multiplication. But what PyTest has done for us is automate the process of at least pointing out that error for us. And if I now go in and fix this, let me go ahead and the light bulb has gone off. I changed the plus to a multiply. Now I'm going to go ahead and after clearing my screen, I'm going to run not Python, but PyTest of testcalculator.py. Crossing my fingers again, and now it's green, and I see just a dot, which indicates that my one and only test passed. I'm good. 100% success with my test now after fixing that bug. All right, let me pause here and see if there's any questions about PyTest, about my file, or what I'm seeing here. Vishal?
Hi, thanks for letting me ask the question. So my question is, what if a user, instead of, because we are taking input from the user, what if the user is somewhat malicious and types in a string instead of an integer? Or maybe he types in a float or some other data type.
Really good question.
Let's say
yeah, so what if the user, like we've seen in past examples, types in cat instead of a number when we're expecting an integer? How do we test for something like that? At the moment, I'm admittedly not testing user input. If I go back to my code here. Notice that my calculator function, of course, has the square function that we keep testing and retesting. But notice that all of the user input is currently relegated to my main function. And admittedly, as of now, I am not testing my main function. So there could be one of those bugs. And in fact, there would be, because if the user types in a string like cat instead of an integer like 2 or 3, then line 2, recall, would actually raise a value error exception. So we've seen that before. So when it comes to testing your code, this is actually a good reason for having multiple functions in your program. Rather than putting all of your logic in just the file itself, rather than putting all of the logic in just main, it's actually really good, really helpful practice to break your ideas up into smaller, bite-sized functions that themselves are testable. And what do I mean here? Square is perfectly testable. Why? Because it takes as input a parameter called n, and it returns as output an integer, which is going to be the square thereof, hopefully. It has a well-defined input and a well-defined output. It is therefore completely within your control in your test program to pass in those values. Now, I will say, if you want to test whether square behaves properly when passed something like a string, like quote unquote cat, we could absolutely do something like this. Assert that the square of quote unquote cat, it's not going to equal something. You can actually, using different syntax, assert that a specific exception will be raised. So if we were actually going to go back into our square function, improve it, and deliberately raise an exception, we could test for that too. But for now, I'm deliberately only testing the square function. I'm not testing for specific user input. But that's another problem to be solved. Other questions now on unit tests? Yeah, Hope?
Do you use the unit test to test code for the CS50 check 50?
So check 50 is similar in spirit. Check 50 is a tool that we, CS50, wrote that is essentially doing something like PyTest for the evaluation of students' code. It is similar in spirit, but think of check 50 as being an alternative to PyTest, if you will. But it works a little bit differently. But same idea. PyTest and unit testing more generally is a technique that is independent of CS50 and is something that you can and should be doing on your own code, both in or outside of this class. How about one other question here on our unit tests? Lavanya?
Am I audible, sir?
Hello.
My question is, instead of writing 4 times like assert square of 2 is equal to 4, instead of that, can we write if I is equals to, in square brackets, the numbers we want, instead of writing 4 lines?
A really good question. Absolutely. Right now, if I go back to testcalculator.py, it's indeed pretty manual. I mean, it took me a while to say and to type out those several lines. And you could imagine writing some kind of loop to just assert in a loop that this equals that this equals that, and so forth, using a list or using maybe a list or a dictionary or some structure like that. So yes, you can absolutely automate some of these tests by not just doing the same thing again and again. You can still use all of the syntax of Python to do loops. But generally speaking, your tests should be pretty simple. And in fact, let me propose that we improve upon even this design further, because at the moment, what's not really ideal when I run all of this, when I run all of these tests, when my function is buggy, is notice the output that I got. Let me reintroduce that same bug by changing my multiplication back to addition. Let me increase the size of my terminal window again, and let me run PyTest again of testcalculator.py. So this is the version of my code now that has the bug again. So I'm going to see that big, massive failure where this failure has been displayed to me. But this is not as helpful as it could be, right? Because I have all of those other tests in my code. Recall that I had, what, 1, 2, 3, 4, 5 separate tests, and I'm only seeing the output of the first. Now, why is that? Well, if we go back to my code here, you'll see that the first assertion that's failing, namely this one here, that assert of square of 3 equals 9, the other tests aren't even getting run. And that's not a big deal in the sense that my code is buggy, so one or more of them are probably going to fail anyway. But wouldn't it be nice to know which of them are going to fail? And in fact, it's ideal to run as many tests all at once as possible to give you as many clues as possible to finding your bug. So let me propose that we improve the design of my testing code now, still using PyTest as follows. Instead of having one big function called test square that tests the entire function itself with so many different inputs, let's break down my tests into different categories. And here too, there's no one right way to do this, but my mind is thinking that I should maybe test positive numbers separately, test negative numbers separately, and test 0 separately. I could think of other ways. I could test even numbers, I could test odd numbers, or maybe some other pattern altogether. But separating this big test into multiple tests is probably going to yield more clues for me when something goes wrong. So let me do this. Let me go ahead and rename this function to test positive initially, and let me include in that function only those first 2 tests. Let me then create another function here called test negative. And in this function, let me test only -2 and -3. Then down here, let me do one more def of test 0, and I'll just run one test in there. So I have the same assertions, the same 5, but I've now divided them up among 3 separate functions. What's nice about PyTest and other unit testing frameworks is that all 3 of these test functions will be run automatically. Even if one of them fails, the others will be attempted. That means that if 1 or 2 or 3 of them fail, I'll have 1 or 2 or 3 clues now for helping me find that mistake. So let me go ahead and again increase the size of my terminal window just so we can see more on the screen. My calculator still has the bug using addition instead of multiplication. Let me go ahead and run not Python, but again, PyTest of testcalculator.py, crossing my fingers as always. And now, oh my God, there's even more errors on the screen. But this in itself is more helpful. Let's work through them from top to bottom. So under failures here, in all caps, which I know is not very encouraging to see failure when you're just trying to solve a problem, but that's what these frameworks do. Under failures, the first function that failed is test positive. But here too, we see the same clue as before. The first one, 2, the square of 2 equals 4, that one's fine. It's not erring with any red errors, but the next one is failing. So I know that square is broken when I pass in 3. All right, what about down here? It looks like, unfortunately, my test negative function is failing too. Why? Well, when I pass in, oh, this is interesting. Here now, -2 doesn't even work. So I got lucky with +2, but -2 isn't working. So that's a bit of a clue. But in total, only 2 tests failed. So notice at the very bottom, this summary, 2 failed and 1 passed. What's the other one? Well, it was the third one, test 0. So test 0 is passing. These 2 are failing. And so that kind of leads me logically, mathematically, if you will, to the source of the bug. And just to be clear, too, if you have a lot of tests, this little one-line output is helpful, even though also a bit discouraging. Fail, fail, and dot means pass. So there are the 3 tests just depicted graphically a little bit differently. Well, let me rewind now and go back into calculator.py. Let's fix that bug, because let's suppose that I've deduced, OK, I'm using addition. I should have been using multiplication all this time. Let me now, after fixing the bug yet again, let me go back to my big terminal. Let me run PyTest of testcalculator.py, hitting Enter, crossing my fingers now, and ... means all is well. 100% of my tests passed, all 3 of them. So now I'm good. It doesn't necessarily mean that my code is 100% correct, but it does mean that it has passed 100% of my current tests. And so it would probably behoove us to think a little harder about maybe we should test bigger numbers, maybe we should test even smaller numbers, maybe we should test strings or something else. The onus is ultimately on you to decide what you're going to test. But in the real world, you're going to be very unhappy with yourself or someone else. Maybe your boss is going to be very unhappy with you if you did not catch a bug in your code, which you could have caught had you just written a test to try that kind of input. All right, let me pause again and see if there's any questions now on unit testings with PyTest. Yeah, Anjali, over to you.
Hi, it's Anjali.
Anjali, yes.
So if you wanted to test, like someone suggested before, user input as well as testing your function, do you do that within the same file, or do you make separate files for different types of tests?
Really good question. You could absolutely make separate files to test different types of things. Or if you don't have that many, you can keep them all in the same file. At the moment, I've been storing all of my tests in one file for convenience, and there's not terribly many of them. But we'll take a look in a bit at an example that allows me to put them into a folder and even run PyTest on a whole folder of tests as well. So that's possible. Other questions on unit testing? Yeah, Piyush?
Can you hear me?
Yes, we can.
Hi. So I've got 2 questions. So a couple of while ago, you just used an exception called assertion. I'm not sure what was. Oh yeah, assertion error. What exactly does that particular error catch? And my second question is, does the assert keyword stand out to the compiler and exactly tell them to assert this particular line of code?
Indeed. The assert keyword we're seeing and the assertion error we saw earlier are intertwined. So when you use assert and the assertion fails, because whatever Boolean expression you're using is not true, it's false, an assertion error, by definition of Python, will be raised. So those two work in conjunction. Those errors, those assertion errors, are still being raised by my code here when any of these lines of code fail. However, PyTest, this third-party library, is handling the process of catching those exceptions automatically for me so as to give me this standard output. So we started today's story by really implementing unit testing myself. I wrote all of the code myself. I wrote main. I did my conditional. I did try and except. Honestly, it's going to get incredibly painful to write tests long term if you and I have to write that much code every time, especially when our function is this small. So PyTest and unit testing frameworks like it just automate so much of that. Essentially, PyTest adds the try, the except, the if, the prints for you, so you can just focus on the essence of the tests, which really are these inputs and outputs. How about time for one other question here on unit testing as well? Yeah, over to Jayesh, if I'm saying it right.
Yes, sir. Sorry. Am I audible, sir?
Yes, we can hear you.
Okay. Sir, when we enter -6 or -5, the square or square root of that number comes up. But when we put 6.6 or 5.6, something like that integer, then line shows error. So what's happening there?
What's happening there if you pass in a float instead of?
Yes.
So if I'm deliberately testing integers right now, in large part because I only want POW to operate on integers. And that might be conveyed in Python's documentation or my own documentation for that function. If we were to pass in something else like a float, it turns out that floating point values in Python and other languages are actually very hard, if not impossible, to represent 100% precisely. And so if you are trying to compare it against some other value, they might be slight rounding errors as a result. I'm just inferring from what you've described, but I'm very deliberately now testing this function with only the inputs that I would expect. It might indeed throw other errors if other inputs are passed. All right, allow me to propose, in fact, that we consider not just testing code that deals with integers as inputs and outputs, which, as all things go, is relatively straightforward. What if we're dealing with strings as well? And let me rewind us in time here in VS Code to that very first program we wrote a few different versions of in hello.py that ultimately looked a little something like this. I had a main function that prompted the user for the value of a variable by asking them, what's your name, question mark. And then we went ahead and did something like hello, open paren name, passing that user's name into a function called hello. Now that function hello, recall, ultimately looked like this. We defined hello as taking a parameter called 2, the default value of which was world, and that function very simply printed hello, followed by a comma, and then whatever the name that had been passed in. And then we ultimately called main, but for now onward, I'm going to always add this if conditional. If name equals underscore underscore main, then and only then do I want to call main. So that's essentially what this program looked like in its last incarnation. How do we go about testing it? Well, here again, too, I'm not going to test the user's input per se in main. I'm going to focus really on the module of code here that's of interest, which is the hello function itself. How can I go about testing the hello function? Well, unfortunately, even if I start by doing something like code of test hello.py, let me go about and start writing a test program. I could import from my hello program a function called hello. So a bit strange to see from hello import hello, but notice that on this line here, I'm importing from the module, that is the file called hello.py, the function called hello. And how do I go about testing this? Well, if I have a function like define test argument like this, well, let me do this. So if I were to define a function like define test hello, what could I do? Well, I could call hello with quote unquote, say, David, and then check if it equals what? Hello, comma, David? So would this work, this approach here? If I've written a test called test hello that calls hello with an argument of David and then tests its return value, just like we've done for our calculator, would this work as written? And let me go back to, in just a moment, the version of hello that we're testing so you can see that function hello. Here's the test. Here's the actual code. Would this test now work? Any thoughts? Yeah, Valentino?
Okay. Yeah, can you hear me?
Yes, we can.
Okay. I think the problem is that in the first version in hello.py, you're using the to argument that you first declare when you declare the function instead of using the name.
Okay, that is actually not a bug here. So let me stipulate that in hello.py, this code actually does work as intended. And let me go ahead and test it manually just to demonstrate as much. Let me run Python of hello.py, typing in as my name, David, and I see, in fact, that it says hello, David. If, though, I were to change this program and get rid of the name argument, get rid of the name variable, and just call hello, again running Python of hello.py, this time I'm not even prompted because I got rid of my input call, but it does behave as I expect. It does say hello world. So let me stipulate that this code in its current form is actually correct, but my test is not going to work as I'd hoped. And there's a subtle difference between hello versus my pow function that there's a subtle difference between my hello function and my square function that explains. Why might this test not work as intended? Michael?
Because it's not returning a value.
Yeah, exactly. Recall our discussion early on about functions. Functions can either return a value, like my square function hands you back the square of some value, or they can have side effects, sort of visual artifacts that might happen on the screen, like printing something out on the screen. And by definition, that's how print works. Notice that hello, it is short, but it's implemented ultimately using the print function, which does not return a value as I'm using it here. It instead has this side effect of printing something onto the screen. So it is not correct in my test function to check if the return value of hello equals hello David, because again, hello is not returning anything. It's printing something, that side effect, but notice literally it has no return keyword, unlike my square function, which did. So here's an opportunity too to perhaps change how I go about implementing my actual functions. It turns out that as your programs get more and more sophisticated, more and more complicated, it tends to be best practice not to have side effects if you can avoid it, especially if you want your code to be testable. And in fact, I'm going to propose that we change my hello program to now work as follows. Let me go ahead and change this function to not print hello and then that name. Let me go ahead and literally return maybe an f string, which will clean this up a little bit, hello, comma, 2, close quote at the end. So my syntax here is just the familiar f string or format string. It's going to return hello world or hello David or hello whoever's name is passed in as that argument. But I'm returning it now. I'm not printing it out. So what needs to change up here? Well, I could do something like this. I could say something like output equals hello and then print output in my main function. Or I can simplify that because I don't really need that variable. I could instead just do this. I could still call hello, but I could immediately print out the result. And this version of my hello program now is actually more testable. Why? Because these assert statements that we're using, and we've seen thus far for our tests, are really designed to test arguments into functions and return values therefrom, not testing side effects. So if you're doing equals equals, you're looking for a return value, something that's handed back from the function. So that's fine. If I modify the design of my program now, not to just print hello, but to return the string, the sentence, the phrase that I want to construct, I can leave it to the caller, that is the function who's using this hello function, to handle the actual printing. Now what does this mean in my code? Well, it means now if my hello.py looks like this, and hello is indeed returning a value, in my test hello function, I can test it exactly like this. So let me go ahead now and run PyTest of test_hello.py, crossing my fingers, and it passed, because passing in David does apparently return hello, comma, David. Well, let's do one other test too. Let's call hello without any arguments. And I think that the return value there should be hello world by default, because the default value of its parameter was meant to be world. So let me test this too. Oh, and I cheated here. Let me rewind here. Apologies. I think we'll fix this later. Let me now go back to my test_hello.py file and actually run it now, and we'll see that the one test we're running is to assert that the return value of hello David equals quote unquote hello David. So let me go ahead and run PyTest of test_hello.py, crossing my fingers as always, and voila, one passed. So I passed this test because apparently the return value of hello does indeed equal hello, comma, David. Well, let's test the other scenario. What if I call hello without any arguments? Let's assert that calling hello with nothing in those parentheses similarly equals hello, comma, but world, the default value. Let me now go ahead and run PyTest of test_hello.py, and that too passes entirely. But there too, suppose that I had made some mistakes, suppose that there were a bug in my code, it might not be best practice to combine multiple tests in this one function. So let's make it more clear what might pass or fail. Let's call the first function test the default to this function, and let's only include this first line of code. And then let's go ahead and define another function like test argument to test this other line of code here. So now I have two different tests, each of which is testing something a little fundamentally different. So now when I run my code, it's still not broken. If I run PyTest of test_hello.py, enter, I've now passed two tests. And that's just as good as before. But if I did have a bug, having two tests instead of one would indeed give me perhaps a bit more of a hint as to what's wrong. Questions now on this testing of return values when these return values are now strings instead of integers, and why we've done this. Yeah, Alan, if I'm saying it right, or Alan?
Alan. Yes, Alan. So my question is about function inside the function. Can we test that too? Or recursion we have in C?
If you have a recursive function, which we've not discussed in this class, yes, you can absolutely test those too by simply calling them exactly in this way. Recursion does not affect this process. Other questions on testing in this way? Yeah, over to Justice. Oh, function middle screen is frozen on me. Sorry, one second. There we go. Justice? Still muted, though. I'm afraid we're not hearing you. Justice, if you don't mind asking via the chat, I'm afraid I can't hear you here, but we'll do our best to answer in the chat. Rohit, over to you. Rohit?
Hello?
You're on the internet.
Hello?
Hello?
Hello. My question was, can we test input?
Yes. Can you test input? You can. And I've not done this here, but it turns out it's a little more involved to test user input. And the syntax for doing so is a little bit more intricate. So for today's purposes, we'll focus only on testing individual functions and leave for another time the testing of input itself. All right, how about one more question here on unit test before we look at one final example? Golkitskin, I'm sorry if I'm not saying that right.
Yeah, that's right. Thank you. When testing our arguments, like can we use something like loops or inside of asserts or for the values?
Absolutely. You can absolutely use a loop to test multiple values. In this case, for instance, I could do something like this. I could say for name in the following list of Hermione, say Harry, and Ron, I could then, within this loop, assert that hello of that given name equals, say, the format string of hello, comma, name, and then run all of these here at once by running, again, pytest of test_hello.py, it's still going to be just one test within that function. But if there's something interesting about those several strings that makes it compelling to test all of them, you can absolutely automate the tests in that way. With that said, each of your tests should ideally be pretty simple and pretty small. Why? Because you don't want to write so much code, so much complicated code that your tests might be flawed. But what we don't want to have to do is write tests for our tests and tests for our tests for our tests, because it would never end. So keeping tests nice and simple is really the goal, so that a reasonable human, yourself included, can eyeball them and just claim, yeah, that is correct. We don't need tests for our tests. Allow me to propose that we do one final thing here, particularly if we end up having lots of tests instead of just one. We might want to start organizing these tests into a folder. And it turns out that we can do this here as well. Let me propose that I create a new folder this time using makedir, M-K-D-I-R, and create a folder called test. Then I'm going to, within that folder, sorry, let me think for a moment. We haven't introduced these commands, but we will in the online version of the class, rest assured. Give me just a moment to think. Test hello. OK. Code. All right, and how about one final feature? Suppose that we have not just one test in one file, but we have a whole bunch of tests such that we want to organize all of those tests in a folder. That, too, is standard practice, and PyTest supports that as well. So for instance, suppose that I want to continue testing this program, hello.py, even though it itself doesn't have many functions. I could go about creating a folder called test, as by typing, damn it, one sec. OK, try that once more. Apologies. Let's introduce one other feature as well. Suppose that you want to test this program with multiple tests with so many, sorry. All right, how about one other feature? Suppose that we don't have just one test, but many different tests instead, and we want to start to organize those tests into multiple files and even a folder. Well, PyTest and other frameworks support that paradigm as well. In fact, let me go ahead and test hello.py using a folder of tests with technically just one test, but it would be representative of having even more in that folder. I'm going to go ahead and create a new folder called test using makedir at my command line, and then within that file, within that folder, I'm going to go ahead and create a file called test_hello.py. Within this file, meanwhile, I'm going to test the same things. I'm going to go ahead and from hello, import hello. And I'm going to go ahead and define a function like test default that simply tests the scenario where hello with no arguments returns hello, comma world. And I'm going to have that other function where I test that an argument is passed. And in this case, I'll choose an argument like asserting that hello, quote unquote, David equals indeed hello, comma, not world, but David. So in this case, I've just recreated the same test as earlier, but they're in a file now in a folder called test. Well, PyTest allows me to run these here too, but to do so, I actually need to create one other file. Within my test directory, I need to create a file called __init__.py, which has the effect, even if this file is empty, of telling Python to treat that folder as not just a module, but a package, so to speak. A package is a Python module or multiple modules that are organized inside of a folder. And this file, __init__py, is just a visual indicator to Python that indeed it should treat that folder as a package. If I had more code in this folder, I could do even more things with this file. But for now, it's just a clue that it's indeed meant to be a package and not just a module or file alone. What I can now do in closing is run PyTest, not even on that specific file, but on a whole folder of tests. So if I run PyTest of test, where the test is the name of that folder, PyTest will automatically search through that folder looking for all possible tests. Granted, there's just those two in this one file, But when I run it now with enter, I'll still pass those tests. I'll still get 100%. And I now have a mechanism ultimately for testing my own code. So whether you're writing functions that return integers or something else, functions that have side effects that could be rewritten as functions that return values, you now have a mechanism to not just wait for someone like us to test your code, and not just test your code manually again and again, which might get tedious and you might make mistakes by not including some possible inputs. We now have an automated mechanism for testing one's own code that's going to be even more powerful when you start collaborating with others, so that you can write tests that ensure that if they make a change to the same code, they haven't broken the code that you've written. All that and more in the days to come. We'll see you next time. OK, we're going to take a 10-minute break now, and we'll transition to file I/O. So we'll see you in 10 or so minutes. Okay. All right, we are back. Casually first. Any questions about anything we just did or what's about to happen before we dive in? The next lecture will be on file I/O, and when that one ends, we'll be done. Any questions here from the group? Yeah, Yorgo?
Hi, can you hear me?
Yes.
Hi. Hi. Thanks for teaching us. Thank you so much. I just wanted to make sure I understood underscore init underscore dot py. What does that tell Python that the file of the folder is?
It tells Python that it's a package, which means that it's a library. And it essentially makes it easier for Python to load other files. So for instance, very concretely, notice that if I open up my test directory, which contained this file. So in my test directory, we ended up with this file that it just imported from hello, import hello. What's that? Oh, yes, thank you. So what I've just done here, Yorgo, is opened up test_hello.py in my test folder. And notice that it's importing from hello, import hello. But recall that my hello.py file is not in the test folder. It's one level up. So among the things the package technique does is it just makes it possible for Python to find the hello file. It's stuff like that. This is sort of annoying Python convention that just works, but without it being as obvious as it could be. Oh, still muted. Oh, back to Yorgo. Sorry, Yorgo, we lost you on the screen. Coming back? Yes. Oh, still mute. There we go.
Oh, thank you. Sorry. So otherwise, would Python not find the file to test?
Yeah, I think so. Let me try this. Let me remove the init file. All right, so I've just removed init.py, and now I'm going to run pytest on that folder again and hit enter, and you get all of these module errors. So I deliberately did it the right way so as to not trip over this error.
Thank you so much.
Sure. How about time for one or two other questions before we forge ahead? Yeah, Rohit?
Hello?
Yep. Hello.
Oh. My question is, how can we know where we create our directory?
Say that once more.
How can we know where we create our directory?
How did I know where to create the test directory?
Yes, yes.
So that's just a convention. Like when you start writing bigger projects that have many tests, it's just convenient to organize them in a folder called test. It doesn't have to be called test. You could call it anything you want, but there's certain conventions in a lot of programming languages, and that would be one. You could call it test. You could call it tests plural. The point, though, is it just kind of keeps your folder clean, so you don't have 100 files all in one place. You can organize them a little more cleanly. How about one other question before we dive into file I/O? Lavanya, if I'm saying it right?
Yes, my question is, it's general in Python. Generally, in print in double quote, if you write \n, we'll be going to the new line. But if you want to print \n, how will we do it?
Sure, yeah, unrelated to the previous talk, if we rewind, recall that we talked about new line characters as \n. If you want a literal backslash, you do \n. So you escape the escape character. And that's a common paradigm. If one doesn't do it, try two. But that's not always the case. But a good question. All right, give me just a moment to get set up here. We're about to dive into file I/O. And as always, please forgive if we can't get to everyone's questions. But my colleague Carter, if you don't mind chiming in the chat, is available if you want to ask questions within the chat. We'll do our best between him and me to answer them either on screen or off. Yep, give me just a moment. All right, this is CS50's Introduction to Programming with Python. My name is David Malan, and this is our week on File I/O, input and output of files. So up until now, most every program we've written just stores all the information that it collects in memory, that is, in variables or inside of the program itself, a downside of which is that as soon as the program exits, anything you typed in, anything that you did with that program is lost. Now with files, of course, on your Mac or PC, you can hang on to information long term. And File I/O within the context of programming is all about writing code that can read from, that is load information from, or write to, that is save information to, files themselves. So let's see if we can't transition then from only using memory and variables and the like to actually writing code that saves some files for us and therefore data persistently. Well, to do this, let me propose that we first consider a familiar data structure, a familiar type of variable that we've seen before, that of a list. And using lists, we've been able to store more than one piece of information in the past. Using one variable, we typically store one value. But if that variable is a list, we can store multiple values. Unfortunately, lists are stored in the computer's memory, and so once your program exits, even the contents of those disappear. But let's at least give ourselves a starting point. So I'm over here in VS Code, and I'm going to go ahead and create a simple program using code of names.py, a program that just collects people's names, students' names, if you will. And I'm going to do it super simply initially in a manner consistent with what we've done in the past to get user input and print it back out. I'm going to say something like this. Name equals input, quote unquote, what's your name? Thereby storing in a variable called name the return value of input, as always. And as always, I'm going to go ahead and very simply print out a nice F string that says hello, comma, and then in curly braces name to print out hello David, hello world, however happens to be using the program. Let me go ahead and run this just to remind myself what I should expect. And if I run python of names.py and hit enter, type in my name like David, of course, I now see hello, comma, David. Suppose, though, that we wanted to add support not just for one name, but multiple names, maybe 3 names for the sake of discussion, so that we can begin to accumulate some amount of information in the program such that it's really going to be a downside if we keep throwing it away once the program exits. Well, let me go back into names.py up here at top. Let me proactively give myself a variable, this time called names plural, and set it equal to an empty list. Recall that the square bracket notation, especially if nothing's inside of it, just means give me an empty list that we can add things to over time. Well, what do we want to add to it? Well, let's add 3 names, each from the user. And let me say something like this. For underscore in range of 3, let me go ahead and prompt the user with the input function and getting their name in this variable. And then using list syntax, I can say names.append name to that list. And now I have in that list that given name, 1, 2, 3 of them. Other points to note is I could use a variable here like I, which is conventional. But if I'm not actually using I explicitly on any subsequent lines, I might as well just use underscore, which is a Pythonic convention. And actually, if I want to clean this up a little bit right now, notice that my name variable doesn't really need to exist because I'm assigning it a value and then immediately appending it. Well, I could tighten this up further by just getting rid of that variable altogether and just appending immediately the return value of input. I think we could go both ways in terms of design here. On the one hand, it's a pretty short line and it's readable. On the other hand, if I were to eventually change this phrase to be not what's your name, but something longer, we might want to break it out again into 2 lines. But for now, I think it's pretty readable. Now, later in the program, let's just go ahead and print out those same names, but let's sort them alphabetically so that it makes sense to be gathering them all together, then sorting them and printing them. So how can I do that? Well, in Python, the simplest way to sort a list in a loop is probably to do something like this. For name in names, but wait, let's sort the names first. Recall that there's a function called sorted, which will return a sorted version of that list. Now let's go ahead and print out an F string that says, again, hello, bracket name, close quotes. All right, let me go ahead and run this. So Python of names.py. And let me go ahead and type in a few names this time. How about Hermione? How about Harry? How about Ron? And notice that they're not quite in alphabetical order, but when I hit enter and that loop kicks in, it's going to print out hello Harry, hello Hermione, hello Ron in sorted order. But of course now, if I run this program again, all of the names are lost. And if this is a bigger program than this, that might actually be pretty painful to have to re-input the same information again and again and again. Wouldn't it be nice, like most any program today on a phone or a laptop or desktop or cloud, to be able to save this information somehow instead? And that's where file I/O comes in, and that's where files come in. They are a way of storing information persistently on your own phone or Mac or PC or some cloud server's disk, so that they're there when you come back and run the program again. So how can we go about saving all three of these names in a file as opposed to having to type them again and again? Well, let me go ahead and rewind and simplify just so we can do one thing at a time. And I'm going to go ahead and do this. I'm still going to prompt the user for a name. And I'm going to go ahead and ask them, what's your name as before, storing the return value in a variable. But now I'm going to do something a little different. Suppose I want to store this name and all future names in a file called names.txt for text file. How can I do that? Well, in Python, I could do this. I can give myself a variable called file, for instance, though I could call it anything I want, equals open of quote unquote names.txt and then quote unquote w. So what is this doing? Well, it turns out in Python there is a function called, Well, it turns out in Python there's a function called open that does literally just that. You give it the name of a file to open and a second argument optionally as to how to open it, and it will open the file for you in a way that you can then read from it to get information or write to it to save information. Now, this function here is documented at this URL here in Python's official documentation as always, and ultimately it's going to allow us to do a little something like this. If I go back to VS Code here and don't I do that? All right, sorry, let me just rewind just so we can get this right. Apologies. All right. Let me go ahead and simplify this file and again give myself just a single variable called name and set the return value of input equal to that variable. So what's your name as before? Quote unquote. And now let me go ahead and let me do something more with this value. Instead of just adding it to a list or printing it immediately out, let's save the value of the person's name that's just been typed in to a file. Well, how do we go about doing that? Well, in Python, there's this function called open, whose purpose in life is to do just that, to open a file. But to open it up programmatically so that you, the programmer, can actually read information from it or write information to it. So open is like the programmer's equivalent of like double-clicking on an icon on your Mac or PC. But it's a programmer's technique because it's going to allow you to specify exactly what you want to read from or write to that file. Formally, its documentation is here, and you'll see that its usage is relatively straightforward. It minimally just requires the name of the file that we want to open and optionally how we want to open it. So let me go back to VS Code here, and let me propose now that I do this. I'm going to go ahead and call this function called open, passing in an argument for names.txt, which is the name of the file I would like to store all of these names in. I could call it anything I want, but because it's going to be just text, it's conventional to call it something.txt. But I'm also going to tell the open function that I plan to write to this file. So as a second argument to open, I'm going to put literally quote unquote w for write, and that's going to tell open to open the file in a way that's going to allow me to change the contents. And better yet, if it doesn't even exist yet, it's going to create the file for me. Now, open returns what's called a file handle, a special value that allows me to access that file subsequently. So I'm going to go ahead and assign it equal to a variable like file. And now I'm going to go ahead and quite simply write this person's name to that file. So I'm going to literally type file, which is the variable linking to that file, .write, which is a function, otherwise known as a method that comes with open files that allows me to write that name to the file. And then lastly, I'm going to quite simply go ahead and say file.close, which will close and effectively save the file. So these three lines of code here are essentially the programmer's equivalent to like double-clicking an icon on your Mac or PC, making some changes in Microsoft Word or some other program, and going to file save. We're doing that all in code with just these three lines here. Well, let's see now how this works. Let me go ahead now and run python of names.py and enter. Let's type in a name. I'll type in Hermione. Enter. All right. Where did she end up? Well, let me go ahead now and type code of names.txt, which is a file that happens now to exist because I opened it in write mode. And if I open this in a tab, we'll see there's Hermione. Well, let's go ahead and run names.py once more. I'm going to go ahead and run Python of names.py, enter, and this time I'll type in Harry. Let me go ahead and run it one more time, and this time I'll type in Ron. And now let me go up to names.txt, where hopefully I'll see all three of them here. But no, I've just actually seen Ron. What might explain what happened to Hermione and Harry, even though I'm pretty sure I ran the program 3 times and I definitely wrote the code that writes their name to that file? What's going on here, do you think? Vishal? Oh, still muted.
I think because we are not appending them, we should append the names. Since we are writing directly, it is erasing the old content and it is replacing with the last set of characters that we mentioned.
Exactly. Unfortunately, quote unquote W is a little dangerous. Not only will it create the file for you, it will also recreate the file for you every time you open the file in that mode. So if you open the file once and write Hermione, that worked just fine as we saw. But if you do it again for Harry, if you do it again for Ron, the code is working, but each time it's opening the file and recreating it with brand new contents. So we had one version with Hermione, one version with Harry, and one final version with Ron. But ideally, I think we probably want to be appending, as Vishal says, each of those names to the file, not just clobbering, that is overwriting the file each time. So how can I do this? It's actually a relatively easy fix. Let me go ahead and do this as follows. I'm going to first remove the old version of names.txt, and now I'm going to change my code to do this. I'm going to change the W, quote unquote, to just A, quote unquote, A for append, which means to add to the bottom, to the bottom, to the bottom, again and again. Now let me go ahead and rerun Python of names.py, enter. I'll again start from scratch with Hermione, because I'm creating the file new. Notice that if I now do code of names.txt, enter, we do see that Hermione is back. So after removing the file, it did get recreated, even though I'm using append, which is good. But now let's see what happens when I go back to my terminal. And this time I run Python of names.py again, this time typing in Harry. And let me run it one more time, this time typing in Ron. So hopefully this time, in that second tab, names.txt, I should now see all three of them. But, this doesn't look ideal. What have I clearly done wrong? Something tells me, even though all three names are there, it's not going to be easy to read those back unless you know where each name ends and begins. Hope? Hope?
The English format is not correct. Like the English format is not correct. Like it's incorrect. It's concatenating them.
It is. Well, it appears to be concatenating, but technically speaking, it's just appending to the file. First Hermione, then Harry, then Ron. It has the effect of combining them back to back, but it's not concatenating per se. It really is just appending. Let's go to another hand here. What really have I done wrong? Or equivalently, how might I fix? It would be nice if there were some kind of gaps between each of the names so we could read them more cleanly. How about we call on Olena? Over to you.
Hello. We should add a new line before we write new name.
Good. We want to add a new line ourselves. So whereas print by default, recall, always outputs automatically a line ending of \n unless we override it with the named parameter called end, write does not do that. Write takes you literally. And if you say write Hermione, that's it. You're getting the H through the E. If you say write Harry, you get the H through the Y. You don't get any extra new lines automatically. So if you want to have a new line at the end of each of these names, we've got to do that manually. So let me again close names.txt and let me remove the current file. And let me go back up to my code here. And I can fix this in any number of ways, but I'm just going to go ahead and do this. I'm going to write out an f string that contains name and \n at the end. We could do this in different ways. We could manually print just the new line or some other technique. But I'm going to go ahead and use my f strings, as I'm in the habit of doing, and just print the name and the new line all at once. I'm going to go ahead now and down to my terminal window, run Python of names.py again, enter. We'll type in Hermione. I'm going to run it again, type in Harry. I'm going to type it again, and this time Ron. Now I'm going to run code of names.txt and open that file. And now it looks like the file is a bit cleaner. Indeed, I have each of the name on its own line, as well as a line ending, which ensures that we can separate one from the other. Now, if I were writing code, I bet I could parse, that is, read the previous file by looking at differences between lowercase and uppercase letters, but that's going to get messy quickly. Generally speaking, when storing data long term in a file, you should probably do it somehow cleanly, like doing one name at a time. Well, let's now go back, and I'll propose that this code is now working correctly, but we can design it a little bit better. It turns out that it's all too easy when writing code to sometimes forget to close files. And sometimes this isn't necessarily a big deal, but sometimes it can create problems. Files could get corrupted or accidentally deleted or the like, depending on what happens in your code. So it turns out that you don't strictly need to call close on the file yourself if you take another approach instead. More Pythonic when manipulating files is to do this, to introduce this other keyword called, quite simply, with, that allows you to specify that in this context, I want you to open and automatically close some file. So how do we use with? It simply looks like this. Let me go back to my code here. I've gotten rid of the close line, and I'm now just going to say this instead. Instead of saying file equals open, I'm going to say with open, then the same arguments as before, and somewhat curiously, I'm going to put the variable at the end of the line. Why? That's just the way this is done. You say with, you call the function in question, and then you say as, and specify the name of the variable that should be assigned the return value of open. Then I'm going to go ahead and indent the line underneath so that the line of code that's writing the name is now in the context of this with statement, which just ensures that automatically, if I had more code in this file down below, no longer indented, the file would be automatically closed as soon as line 4 is done executing. So it doesn't change what has just happened, but it does automate the process of at least closing things for us, just to ensure I don't forget and so that something doesn't go wrong. But suppose now that I wanted to read these names from the file. All I've done thus far is write code that writes names to the file. But let's assume now that we have all of these names in the file. And heck, let's go ahead and add one more. Let me go ahead and run this one more time, Python of names.py. And let's add in Draco to the mix. So now that we have all 4 of these names here, how might we want to read them back? Well, let me propose that we go into names.py now, or we could create another program altogether, but I'm going to keep reusing the same name just to keep us focused on this. And now I'm going to write code that reads an existing file with Hermione, Harry, Ron, and Draco together. And how do I do this? Well, it's similar in spirit. I'm going to start this time with open. And then the first argument is going to be the name of the file that I want to open, as before. And I'm going to go open it this time in read mode, quote unquote R. And to read a file just means to load it, not to save it. And I'm going to name the return value file. And now I'm going to do this. And there's a number of ways I can do this. But one way to read all of the lines from the file at once would be this. Let me declare a variable called lines. Let me access that file and call a function or a method that comes with it called readLines. So if you read the documentation on file IO in Python, you'll see that open files come with a special method whose purpose in life is to read all of the lines from the file and return them to me as a list. So what this line 2 is doing is it's reading all of the lines from that file, storing them in a variable called lines. Now suppose I want to iterate over all of those lines and print out each of those names. For line in lines, this is just a standard for loop in Python. Lines is a list. Line is the variable that will be automatically be set to each of those lines. Let me go ahead and print out something like, oh, hello, comma, and then I'll print out the line itself. All right, so let me go to my terminal window, run Python of names.py now. I have not deleted names.txt, so it still contains all 4 of those names, and hit enter. And OK, it's not bad, but it's a little ugly here. What's going on? When I ran names.py, it's saying hello to Hermione, to Harry, to Ron, to Draco, but there's these gaps now between the lines. What explains that symptom? If nothing else, it just looks ugly. Rafal, if I'm saying it right?
Yeah, that's right. It happens because in the text file, we have new line symbols in between those names, and the print always adds another new line at the end. So you use the same symbol twice.
Perfect. And here's a good example of a bug, a mistake in a program. But if you just think about those first principles, like how do each of the lines of code work that I'm using, you should be able to reason exactly as Rafal did there to say that, all right, well, one of those new lines is coming from the file after each name. And then, of course, print all of these weeks later is still giving us for free that extra new line. So there's a couple of possible solutions. I could certainly do this, which we've done in the past, and pass in a named argument to print, like end equals quote unquote. And that's fine. I would argue a little better than that might actually be to do this, to strip off of the end of the line the actual new line itself, so that print is handling the printing of everything, the person's name as well as the new line. But you're just stripping off what is really just an implementation detail in the file. We chose to use new lines in my text file to separate one name from another. So arguably, it should be a little cleaner in terms of design to strip that off and then let print out what is really just now a name. But that's ultimately a design decision. The effect is going to be exactly the same. Well, if I'm going to open this file and read all the lines and then iterate over all of those lines and print them each out, I could actually combine this into one thing. Because right now, I'm doing twice as much work. I'm reading all of the lines, then I'm iterating over all of the lines just to print out each of them. Well, in Python with files, you can actually do this. I'm going to erase almost all of these lines now, keeping only the with statement at top. And inside of this with statement, I'm going to say this. For line in file, go ahead and print out, quote unquote, hello, comma, and then line.rstrip. So I'm going to take the approach of stripping off the end of the line. But notice how elegant this is, so to speak. I've opened the file in line 1. And if I want to iterate over every line in the file, I don't have to very explicitly read all the lines, then iterate over all of the lines. I can combine this into one thought. In Python, you can simply say for line in file. And that's going to have the effect of giving you a for loop that iterates over every line in the file one at a time. And on each iteration, updating the value of this variable line to be Hermione, then Harry, then Ron, then Draco. So this, again, is one of the appealing aspects of Python, is that it reads rather like English. For line in file, print this. It's a little more compact when written this way. Well, what if, though, I don't want quite this behavior? Because notice now, if I run python of names.py, it's correct. I'm seeing each of the names and each of the hellos, and there's no extra spaces in between. But just to be difficult, I'd really like us to be sorting these hellos. Really, I'd like to see Draco first, then Harry, then Hermione, then Ron, no matter what order they appear in the file. So I could go in, of course, to the file and manually change the file. But if that file is changing over time based on who is typing their name into the program, that's not really a good solution. In code, I should be able to load the file no matter what it looks like and just sort it all at once. Now, here is a reason to not do what I've just done. I can't iterate over each line in the file and print it out, but sort everything in advance, right? Logically, if I'm looking at each line one at a time and printing it out, it's too late to sort. I really need to read all of the lines first without printing them, sort them, then print them. So we have to take a step back in order to add now this new feature. So how can I do this? Well, let me combine some ideas from before. Let me go ahead and start fresh with this. Let me give myself a list called names and assign it an empty list, just so I have a variable in which to accumulate all of these lines. And now let me open the file with open, quote unquote, names.txt. And it turns out, I can tighten this up a little bit. It turns out if you're opening a file to read it, you don't need to specify quote unquote R. That is the implicit default. So you can tighten things up by just saying open names.txt, and you'll be able to read the file, but not write it. I'm going to give myself a variable called file, as before. I am going to iterate over the file in the same way for line in file, but instead of printing each line, I'm going to do this. I'm going to take my names list and append to it, and this is appending to a list in memory, not appending to the file itself. I'm going to go ahead and append the current line, but I'm going to strip off the new line at the end so that all I'm adding to this list is each of the students' names. Now I can use that familiar technique from before. Let me go outside of this with statement, because now I've read the entire file, presumably. So by the time I'm done with lines 4 and 5, again and again and again for each line in the file, I'm done with the file. It can close. I now have all of the students' names in this list variable. Let me do this. For name in, not just names, but the sorted names, using our Python function sorted, which does just that, and do print, quote unquote, with an f string, hello, comma, and now I'll plug in bracket name. So now what have I done? I'm creating a list at the beginning just so I have a place to gather my data. I then, on lines 3 through 5, iterate over the file from top to bottom, reading in each line one at a time, stripping off the new line and adding just the student's name to this list. And the reason I'm doing that is so that on line 7, I can sort all of those names now that they're all in memory and print them in order. I need to load them all into memory before I can sort them. Otherwise, I'd be printing them out prematurely, and Draco would end up last instead of first. So let me go ahead in my terminal window and run Python of names.py now and hit enter. And there we go. The same list of 4 hellos, but now they're sorted. And this is a very common technique when dealing with files and information more generally. If you want to change that data in some way, like sorting it, creating some kind of variable at the top of your program like a list, adding or appending information to it just to collect it in one place, and then do something interesting with that collection, that list, is exactly what I've done here. Let me pause and see if there's any questions now on file I/O, reading or writing, or now accumulating all of these values in some list. Yeah, Nathan, question?
Hi, is there a way to sort the files, but instead if you want it from alphabetically from A to Z, is there a way to reverse it from Z to A? Is there like a little extension that you can add to the end to do that, or would you have to create a new function?
If you wanted to reverse the contents of the file? Did I hear you right?
Yeah, so if you, instead of sorting them from A to Z in ascending order, if you wanted them in descending order, is there an extension for that?
There is indeed. And as always, the documentation is your friend. So if the goal is to sort them, not in alphabetical order, which is the default, but maybe reverse alphabetical order, you can take a look, for instance, at the formal Python documentation there. And what you'll see is this summary. You'll see that the sorted function takes a first argument, generally known as an iterable. And something that's iterable means that you can iterate over it. That is, you can loop over it, one thing at a time. What the rest of this line here means is that you can specify a key, like how you want to sort it, but more on that later. But this last named parameter here is reverse. And by default, per the documentation, it's false. It will not be reversed by default. But if we change that to true, I bet we can do that. So let me go back to VS Code here and do just that. Let me go ahead and pass in a second argument to sorted in addition to this iterable, which is my names list. Iterable again in the sense that it can be looped over. And let me pass in reverse equals true, thereby overriding the default of false. Let me now run Python of names.py, and now Ron's at the top and Draco's at the bottom. So there too, whenever you have a question like that moving forward, consider what does the documentation say and see if there's a germ of an idea there, because odds are if you have some problem, odds are some programmer before you has had the same question. Other thoughts on these? Maria?
Hello, David. Can we limit numbers of names? And the second question, can we find specific name in list?
Really good question. Can we limit the number of the names in the file, and can we find a specific one? We absolutely could. If we were to write code, we could, for instance, open the file first, count how many lines are already there, and then if there's too many already, we could just exit with sys.exit or some other message to indicate to the user that, sorry, the class is full. As for finding someone specifically, absolutely. You could imagine opening the file, iterating over it with a for loop again and again, and then adding a conditional. Like if the current line equals Harry, then we found the chosen run. And you can print something like that. So you can absolutely combine these ideas with previous ideas like conditionals to ask those same questions. How about one other question on file I/O? Yeah, how about over to Philip?
Oh, yeah, hello.
So I just thought about this function like read all lines, and it looks like it's like separate all the lines by this special character \n, but it looks like we don't need it character, and we always strip it, and it looks like some bad design of function. Why wouldn't we just strip it inside this function?
A really good question. So we are, in my examples thus far, using rstrip to reverse, strip from the end of the line all of this white space. You might not want to do that. In this case, I am stripping it away because I know that each of those lines isn't some generic line of text. Each line really represents a name that I have put there myself. I'm using the new line just to separate one value from another. In other scenarios, you might very well want to keep that line ending because it's a very long series of text or a paragraph or something like that where you want to keep it distinct from the others. But it's just a convention. We have to use something, presumably, to separate one chunk of text from another. There are other functions in Python that will, in fact, handle the removal of that white space for you. Readlines, though, does literally that, though. It reads all of the lines as is. Well, allow me to turn our attention back to where we left off here, which is just names, to propose that with names.txt, we have an ability, it seems, to store each of these names pretty straightforwardly. But what if we wanted to keep track of other information as well? Suppose that we wanted to store information including a student's name and their house at Hogwarts, be it Gryffindor or Slytherin or something else. Well, where do we go about putting that? You know, Hermione lives in Gryffindor, so we could do something like this in our text file. Harry lives in Gryffindor, so we could do that. Ron lives in Gryffindor, so we could do that. And Draco lives in Slytherin, so we could do that. But I worry here. But I worry now that we're mixing apples and oranges, so to speak. Like some lines are names, some lines are houses. So this probably isn't the best design, if only because it's confusing or it's ambiguous. So maybe what we could do is adopt a convention. And indeed, this is in fact what a lot of programmers do. They change this file not to be names.txt, but instead let me create a new file called names.csv. CSV stands for comma separated values, and it's a very common convention to store multiple pieces of information that are related in the same file. And so to do this, I'm going to separate each of these types of data not with another new line, but simply with a comma. I'm going to keep each student on their own line, but I'm going to separate the information about each student using a comma instead. And so now we sort of have a two-dimensional file, if you will. Row by row, we have our students. But if you think of these commas as representing a column, even though it's not perfectly straight because of the lengths of these names, it's a little jagged, you can think of these commas as representing a column. And it turns out these CSV files are very commonly used when you use something like Microsoft Excel, Apple Numbers, or Google Spreadsheets, and you want to export the data to share with someone else as a CSV file. Or conversely, if you want to import a CSV file into your preferred spreadsheet software like Excel or Numbers or Google Spreadsheets, you can do that as well. So CSV is a very common, very simple text format that just separates values with commas and different types of values ultimately with new lines as well. So suppose now that I have this file called names.csv. And actually, I'm going to make a quick change for our video here. Apologies. Apologies. I'm going to rename this file just for the sake of discussion. And Andrew, Ramon, let me give you guys the audio. Let me go ahead and run. Sorry. Let me go ahead and run code of students.csv and paste all of those same names in, but ... OK, that gives us the footage for that. All right. All right. Give me one moment. Apologies. There we go. All right, I'm going to do that once more just so we get the logic here correct, so I don't break things for us later. Let me go ahead and create a new file called students.csv, pasting in those same names. ... Oh, sure. Apologies. I just need to do something for our video team here. Then we'll get back on track. OK. Giving them some silence deliberately. Let me go ahead and run code of students.csv to create a brand new file that's initially empty, and we'll add to it those same names, but also some other information as well. OK. All right, and Ramon, we can fix it later if need be, I think. OK. So if I now have this new file, students.csv, inside of which is one column of names, so to speak, and one column of houses, how do I go about changing my code to read not just those names, but also those names and houses so that they're not all on one line? We somehow have access to both type of value separately. Well, let me go ahead and create a new program here called students.py. And in this program, let's go about reading, not a text file per se, but a specific type of text file, a CSV, a comma separated values file. And to do this, I'm going to use similar code as before. I'm going to say with open, quote unquote, students.csv. I'm not going to bother specifying quote unquote r, because again, that's the default. But I'm going to give myself a variable name of file. And then in this file, I'm going to go ahead and do this. For line in file, as before. And now I have to be a bit clever here. Let me go back to students.csv, looking at this file, and it seems that on my loop, on each iteration, I'm going to get access to the whole line of text. I'm not going to automatically get access to just Hermione or just Gryffindor. Recall that the loop is going to give me each full line of text. So logically, what would you propose that we do inside of a for loop that's reading a whole line of text at once, but we now want to get access to the individual values, like Hermione and Gryffindor, Harry and Gryffindor? How do we go about taking one line of text and gaining access to those individual values, do you think? Just instinctively, even if you're not sure what the name of the functions would be. Yeah, Dev, your thoughts? Oh, still muted.
You can access it as you would as if you were using a dictionary, like using a key and value.
So ideally, we would access it using a key and value. But at this point in the story, all we have is this loop. And this loop is giving me one line of text at a time. I'm the programmer now. I have to solve this. There is no dictionary yet in question. How about another suggestion here? What can I do once I have this loop here? Anjali, did I get it right this time?
Mm-hmm.
OK. Anjali?
So you can somehow split the two words based on the comma.
Yeah, even if you're not quite sure what function is going to do this, intuitively you want to take this whole line of text, Hermione, comma, Gryffindor, Harry, comma, Gryffindor, and so forth, and split that line into two pieces, if you will. And it turns out wonderfully the function we'll use is actually called split, that can split on any characters, but you can tell it what character to use. So I'm going to go back into students.py, and inside of this loop, I'm going to go ahead and do this. I'm going to take the current line. I'm going to remove the white space at the end, as always, using rstrip here. And then whatever the result of that is, I'm going to now call split and quote unquote comma. So the split function or method comes with strings, strs in Python. Any str has this method built in. And if you pass in an argument like a comma, what this split function will do is split that current string into 1, 2, 3, maybe more pieces by looking for that character again and again. Ultimately, split is going to return to us a list of all of the individual parts to the left and to the right of those commas. So I can give myself a variable called row here. And this is a common paradigm. When you know you're iterating over a file, specifically a CSV, it's common to think of each line of it as being a row. And each of the values therein, separated by commas, as columns, so to speak. So I'm going to deliberately name my variable row, just to be consistent with that convention. And now what do I want to print? Well, I'm going to go ahead and say this. Print, how about the following? An f string that starts with curly braces. Well, how do I get access to the first thing in that row? Well, the row is going to have how many parts? 2. Because if I'm splitting on commas, and there's 1 comma per line, that's going to give me a left part and a right part, like Hermione and Gryffindor, Harry and Gryffindor. When I have a list like row, how do I get access to individual values? Well, I can do this. I can say row, bracket, 0. And that's going to go to the first element of the list, which should hopefully be the student's name. Then after that, I'm going to say is in, and I'm going to have another curly brace here for row bracket 1. And then I'm going to close my whole quote. So it looks a little cryptic at first glance, but most of this is just f-string syntax with curly braces to plug in values. And what values am I plugging in? Well, row, again, is a list, and it has 2 elements, presumably. Hermione in one and Gryffindor in the other, and so forth. So bracket 0 is the first element, because remember, we start indexing at 0 in Python, and 1 is going to be the second element. So let me go ahead and run this now and see what happens. Python of students.py, enter, and we see Hermione's in Gryffindor, Harry's in Gryffindor, Ron is in Gryffindor, and Draco is in Slytherin. So we have now implemented our own code from scratch that actually parses, that is, reads and interprets a CSV file ultimately here. Now let me pause to see if there's any questions, but we'll make this even easier to read in just a moment. Any questions on what we've just done here by splitting by comma? Yeah, Sharia, if I'm saying it right? Oh, no question? OK, someone else? Vishal, question?
Thanks for. So my question is, can we edit any line of code anytime we want, or the only option that we have is to append the lines? Or let's say if we want to, let's say, change Harry's house to, let's say, Slytherin or some other house.
Yeah, a really good question. What if you want to, in Python, change a line in the file and not just append to the end? You would have to implement that logic yourself. So for instance, you could imagine now opening the file and reading all of the contents in, then maybe iterating over each of those lines. And as soon as you see that the current name equals Harry, you could maybe change his house to Slytherin. And then it would be up to you, though, to write all of those changes back to the file. So in that case, you might want to, in simplest form, read the file once and let it close, then open it again, but open for writing and change the whole file. It's not really possible or easy to go in and change just part of the file, though you can do it. It's easier to actually read the whole file, make your changes in memory, then write the whole file out. But for larger files where that might be quite slow, you can be more clever than that. Well, let me propose now that we clean this up a little bit, because I actually think this is a little cryptic to read, row bracket 0, row bracket 1. It's not that well written at the moment, I would say. But it turns out that when you have a variable that's a list, like row, you don't have to throw all of those variables into a list. You can actually unpack that whole sequence at once. That is to say, if you know that a function like split returns a list, but you know in advance that it's going to return 2 values in a list, the first and the second, you don't have to throw them all into a variable that itself is a list. You can actually unpack them simultaneously into 2 variables, doing name, comma, house. So this is a nice Python technique to not only create but assign automatically in parallel 2 variables at once, rather than just 1. So this will have the effect of putting the name in the left, Hermione, and it will have the effect of putting Gryffindor, the house, in the right variable. And we now no longer have a row. We can now make our code a little more readable by now literally just saying name down here and, for instance, house down here. So just a little more readable, even though functionally the code now is exactly the same. All right, so this now works, and I'll confirm as much by just running it once more. Python of students.py, enter, and we see that the text is as intended. But suppose for the sake of discussion that I'd like to sort this list of output. I'd like to say hello again to Draco first, then hello to Harry, then Hermione, then Ron. How can I go about doing this? Well, let's take some inspiration from the previous example where we were only dealing with names and instead do it with these full phrases. So-and-so is in house. Well, let me go ahead and do this. I'm going to go ahead and start scratch and give myself a list called students, equal to an empty list initially. And then with open students.csv as file, I'm going to go ahead and say this. For line in file. And then below this, I'm going to do exactly as before. Name, comma, house equals the current line, stripping off the white space at the end, splitting it on a comma. So that's exact same as before. But this time, before I go about printing the sentence, I'm going to store it temporarily in a list so that I can accumulate all of these sentences and then sort them later. So let me go ahead and do this. Students, which is my list, dot append. Let me append the actual sentence I want to show on the screen. So another f string. So name is in house, just as before. But notice I'm not printing that sentence. I'm appending it to my list. Not a file, but to my list. Why am I doing this? Well, just because, as before, I want to do this. For student in the sorted students, I want to go ahead and print out student, like this. Well, let me go ahead and run Python of students.py and hit enter now. And I think we'll see, indeed, Draco is now first. Harry is second, Hermione is third, and Ron is fourth. But this is arguably a little sloppy, right? It seems a little hackish that I'm constructing these sentences. And even though I'm technically want to sort by name, I'm technically sorting by these whole English sentences. So it's not wrong. It's achieving the intended result. But it's not really well designed because I'm just kind of getting lucky that English is reading from left to right. And therefore, when I print this out, it's sorting properly. It would be better really to come up with a technique for sorting by the students' names, not by some English sentence that I've constructed here on line 6. So to achieve this, I'm going to need to make my life more complicated for a moment, and I'm going to need to collect information about each student before I bother assembling that sentence. So let me propose that we do this. Let me go ahead and undo these last few lines of code so that we currently have two variables, name and house, each of which has name and the student's house respectively, and we still have our global variable students. But let me do this. Recall that Python supports dictionaries, and dictionaries are just collections of keys and values, so you can associate something with something else, like a name with Hermione, like a house with Gryffindor. That really is a dictionary. So let me do this. Let me temporarily create a dictionary that stores this association of name with house. Let me go ahead and do this. Let me say that the student here is going to be represented initially by an empty dictionary. And just like you can create an empty list with square brackets, you can create an empty dictionary with curly braces. So give me an empty dictionary that will soon have two keys, name and house. How do I do that? Well, I could do it this way. Student, open bracket, name, equals the student's name that we got from the line. Student bracket house equals the house that we got from the line. And now I'm going to append to the students list, plural, that particular student. Now, why have I done this? I've admittedly made my code more complicated. It's more lines of code. But I've now collected all of the information I have about students while still keeping track. What's a name? What's a house? The list, meanwhile, has all of the students' names and houses together. Now, why have I done this? Well, let me, for the moment, just do something simple. Let me do for student in students. And let me very simply now say, print the following f string. The current student with this name is in this current student's house. And now notice one detail. Inside of this f string, I'm using my curly braces as always. I'm using inside of those curly braces the name of a variable as always. But then I'm using not bracket 0 or 1, because these are dictionaries now, not list. But why am I using single quotes to surround house and to surround name? Why single quotes inside of this f string to access those keys? Yeah, Armando?
Yes, because you have double quotes in that line 12.
Exactly.
So you have to tell Python to differentiate.
Exactly, because I'm already using double quotes outside of the f string. If I want to put quotes around any strings on the inside, which I do need to do for dictionaries, because recall, when you index into a dictionary, you don't use numbers like lists, 0, 1, 2, onward. You instead use strings, which need to be quoted. But if you're already using double quotes, it's easiest to then use single quotes on the inside so Python doesn't get confused about what lines up with what. So at the moment, when I run this program, it's going to print out those hellos, but they're not yet sorted. In fact, what I now have is a list of dictionaries Nothing is yet sorted, but let me tighten up the code too to point out that it doesn't need to be quite as verbose. If you're in the habit of creating an empty dictionary, like this on line 6, and then immediately putting in 2 keys, name and house, each with 2 values, name and house respectively, you can actually do this all at once. So let me show you a slightly different syntax. I can do this. Give me a variable called student, and let me use curly braces on the right-hand side here, but instead of leaving them empty, let's just define those keys and those values now. Quote unquote name will be name, and quote unquote house will be house. This achieves the exact same effect in 1 line instead of 3. It creates a new non-empty dictionary containing a name key, the value of which is the student's name, and a house key, the value of which is the student's house. Nothing else needs to change. That will still just work, so that if I again run Python of students.py, I'm still seeing those greetings, but they're still not quite actually sorted. Well, what might I go about doing here in order to, what could I do to improve upon this further? Well, we need some mechanism now of sorting those students. But unfortunately, you can't do this. We can't sort all of the students now because those students are not names like they were before. They aren't sentences like they were before. Each of the students is a dictionary, and it's non-obvious how you would sort a dictionary inside of a list. So ideally, what do we want to do? We are currently aspiring to print sentences. Whoops. So what do we want to do? We are okay, let me undo that. So what do we All right, so what do we actually want to do? If at the moment we hit line 9, we have a list of all of these students, and inside of that list is 1 dictionary per student, and each of those dictionaries has 2 keys, name and house. Wouldn't it be nice if there were a way in code to tell Python, sort this list by looking at this key in each dictionary? Because that would give us the ability to sort either by name or even by house or even by any other field that we add to that file. So it turns out we can do this. We can tell the sorted function not just to reverse things or not. It takes another named parameter called key, where you can specify what key should be used in order to sort some list of dictionaries. And I'm going to propose that we do this. I'm going to first define a function temporarily for now called getName. And this function's purpose in life, given a student, is to quite simply return the student's name from that particular dictionary. So if student is a dictionary, this is going to return literally the student's name. And that's it. That's the sole purpose of this function in life. What do I now want to do? Well, now that I have a function that, given a student, will return to me the student's name, I can do this. I can change sorted to say, use a key that's equal to whatever the return value of getName is. And this now is a feature of Python. Python allows you to pass functions as arguments in 2 other functions. So getName is a function, sorted is a function, and I'm passing in getName to sorted as the value of that key parameter. Now, why am I doing that? Well, if you think of the getName function as just a block of code that will get the name of a student, that's handy because that's the capability that sorted needs. When given a list of students, each of which is a dictionary, sorted needs to know, how do I get the name of the student in order to do alphabetical sorting for you? The authors of Python didn't know that we were going to be creating students here in this class, so they couldn't have anticipated writing code in advance that specifically sorts on a field called student, let alone called name, let alone house. So what did they do? They instead built into the sorted function this named parameter key that allows us all these years later to tell their function sorted how to sort this list of dictionaries. So now watch what happens. If I run Python of students.py and hit enter, I now have a sorted list of output. Why? Because now that list of dictionaries has all been sorted by the student's name. I can further do this. If, as before, we want to reverse the whole thing by saying reverse equals true, we can do that too. Let me rerun Python of students.py and hit enter. Now it's reversed. Now it's Ron, then Hermione, Harry, and Draco. But we can do something different as well. What if I want to sort, for instance, by house name reversed? I could do this. I could change this function from getName to getHouse. I could change the implementation up here to be get house, and I can return not the student's name, but the student's house. And so now notice, if I run python of students.py, enter, notice now it is sorted by house in reverse order. Slytherin is first, and then Gryffindor. If I get rid of the reverse, but keep the get house, and rerun this program, now it's sorted by house. Gryffindor is first, and Slytherin is last. And the upside now of this is because I'm using this list of dictionaries and keeping the students' data together until the last minute when I'm finally doing the printing, I now have full control over the information itself, and I can sort by this or that. I don't have to construct those sentences in advance like I rather hackishly did the first time. All right, that was a lot. Let me pause here to see if there are questions. Yeah, let's see. Gotkim, if I'm saying it right. Oh, still muted. There we go.
Yeah, hello. So when we're sorting the files, should we should we use the loops, or like a dictionary or any kind of list? Can we sort by just sorting, not looping or any kind of stuff?
A good question. And the short answer with Python alone, you're the programmer, you need to do the sorting. With libraries and other techniques, absolutely. You can do more of this automatically because someone else has written that code. What we're doing at the moment is doing everything from scratch ourselves. But absolutely, with other functions or libraries, some of this could be made more easily done. Some of this could be made easier. Other questions on this technique here? Yeah, let's see. Abdelaram, if I'm saying it right?
Yeah. Hey, how are you? Okay. In sorted function, in what way the sort function arranged Gryffindor in pose of 3 Gryffindor?
Let's see. I was having a little trouble hearing you. Can you say it once more?
Okay, in what way a sorted function arranged Gryffindor in the 3 Gryffindor?
In what way is sorted arranging things? So sorted will return to you a list of items that are assorted according to whatever the key is. By default, if you just pass sorted a list of strings, which we did earlier, it's just going to sort the strings alphabetically. If, though, you pass sorted a list of dictionaries, and a dictionary, again, is a collection of keys and values, there's no default understanding of what it means to sort things that are dictionaries. You need to tell the sorted function what key in each dictionary should be compared against all the other keys. So I'm currently doing this by house, and I could also do it as before by student, because the authors of Python didn't know that our dictionaries all these years later would have names and houses or other keys as well. Other questions now on this technique? Ibrahim, if I'm saying it right?
Yes, you hear me?
Yes, we can.
No, I just missed the part. What this student CIV includes? Student CIV file includes?
Students.csv only includes these 2 columns, name on the left and house on the right.
Thank you. Thank you. I didn't see it.
How about time for one more question on this CSV approach? Yeah, Piyush? Nope. OK. One more? Oh, Piyush, we actually can't hear you. Even though you're unmuted, maybe your headphones weren't working. Mohammed, over to you.
Mr. David. I have 2 questions, if you
sure.
The first one, the key, can it equal to just a variable, not outcome of get house function? This is my first question.
I'm not sure I caught that. Did you?
The key.
Yeah, the key?
Yes, it equal to the returned value of the function. can it be equal to just a variable or a value?
Well,
Not,
yes, it should equal a value. So I'm specific, and I should clarify actually, since this was not obvious. So when you pass in a function like getName or getHouse to the sorted function as the value of key, that function is automatically called by the sorted function for you on each of the dictionaries in the list. And it uses the return value of getName or getHouse to decide what strings to actually use to compare in order to decide which is alphabetically correct. So this function, which you pass just by name, you do not pass in parentheses at the end, is called by the sorted function in order to figure out for you how to compare these same values. And
the second one.
Oh, sure. Go ahead.
How can we use nested dictionaries? يعني I have read about nested dictionaries. What is the difference between nested dictionaries and dictionary inside a list? I think it is.
Sure. So we are using a list of dictionaries. Why? Because each of those dictionaries represents a student, and a student has a name and a house, and we want to, I claim, maintain that association. And it's a list of students because we've got multiple students, 4 in this case. You could create a structure that is a dictionary of dictionaries, but I would argue it just doesn't solve a problem. I don't need a dictionary of dictionary. I need a list of key value pairs right now. That's all. So let me propose if we go back to students.py here and we revert back to the approach where we have getName as the function, both used and defined here, and that function returns the student's name. What happens to be clear is that the sorted function will use the value of key, getName in this case, calling that function on every dictionary in the list that it's supposed to sort. And that function getName returns the string that sorted will actually use to decide whether things go in this order, left, right, or in this order, right, left. It alphabetizes things based on that return value. So notice that I'm not calling the function getName here with parentheses. I'm passing it in only by its name so that the sorted function can call that getName function for me. Now, it turns out, as always, if you're defining something, be it a variable or in this case a function, and then immediately using it, but never once again needing the name of that function like getName, we can actually tighten this code up further. I can actually do this. I can get rid of the getName function altogether, just like I could get rid of a variable that isn't strictly necessary. And instead of passing key, the name of a function, I can actually pass key what's called a lambda function, which is an anonymous function, a function that just has no name. Why? Because you don't need to give it a name if you're only going to call it in one place. And the syntax for this in Python is a little weird, but if I do key equals literally the word lambda, then something like student, which is the name of the parameter I expect this function to take, and then I don't even type the return key. I instead just say student bracket name. So what am I doing here with my code? This code here that I've highlighted is equivalent to the getName function I implemented a moment ago. The syntax is admittedly a little different. I don't use def. I didn't even give it a name like getName. I instead am using this other keyword in Python called lambda, which says, hey, Python, here comes a function, but it has no name. It's anonymous. That function takes a parameter. I could call it anything I want. I'm calling it student. Why? Because this function that's passed in as key is called on every one of the students in that list, every one of the dictionaries in that list. What do I want this anonymous function to return? Well, given a student, I want to index into that dictionary and access their name so that the string Hermione and Harry and Ron and Draco is ultimately returned. And that's what the sorted function uses to decide how to sort these bigger dictionaries that have other keys like house as well. So if I now go back to my terminal window and run Python of students.py, it still seems to work the same, but it's arguably a little better designed because I didn't waste lines of code by defining some other function, calling it in one and only one place. I've done it all sort of in one breath, if you will. All right, let me pause here to see if there's any questions specifically about lambda or anonymous functions and this tightening up of the code. Soyan? If I'm saying it right?
Professor, it is Swayam. And I have a question like whether we could define lambda twice.
You can use lambda twice. You can create as many anonymous functions as you'd like, and you generally use them in contexts like this where you want to pass to some other function a function that itself does not need a name. So you can absolutely use it in more than one place. I just have only one use case for it right now. Other questions on lambda and these anonymous functions? Rohit?
Hello.
Yes, hello.
My question is not from lambda, but I have a doubt. Can we sort characters from a word?
Can you sort by what?
Characters from a word.
Can you sort the characters in a word? Yes, you can, but let me save that problem for another day. You could absolutely do something like that, but we need to do more work than we're doing here. At the moment, we're operating on strings. How about one other question on lambda or anonymous functions specifically? Philip?
Oh, yeah. What if our lambda would take more than one line, for example? I can't imagine this.
Sure, if your lambda function takes multiple parameters, that is fine. You can simply specify commas followed by the names of those parameters, maybe x and y or so forth, after the name student. So here too, lambda looks a little different from def in that you don't have parentheses, you don't have the keyword def, you don't have a function name, but ultimately they achieve that same effect. They create a function anonymously and allow you to pass it in, for instance, as some value here. Well, let me propose that we're in a good place now, even though this is a lot to digest all at once, because we've gone from just reading files to now writing them and then reading them with multiple fields separated by commas. Unfortunately, our code is still a little fragile. It seems to work fine for these inputs, but suppose that we were to change our CSV file, not to store students' houses, but their homes, like where those students from Hogwarts actually grew up. So let me propose that we actually do this. Suppose that we jot down that, say, Draco lives in Slytherin now, but grew up in Malfoy Manor. Fix this. Sorry, just one moment. OK. Let's make a change. So let's now change students.csv to contain not students' houses at Hogwarts, but their homes where they grew up. So Draco, for instance, grew up in Malfoy Manor. Ron grew up in the Burrow. Harry grew up in number 4 Privet Drive. And according to the internet, no one knows where Hermione grew up. The movies apparently took certain liberties with where she grew up. So for this purpose, we're actually going to remove Hermione because it is unknown exactly where she was born. So we still have some 3 students. But if anyone can spot the potential problem now, how might this be a bad thing? Well, let's go and try and run our own code here. Let me go back to students.py here, and let me propose that I just change my semantics because I'm now not thinking about Hogwarts houses, but the student's own home. So I'm just going to change some variables. I'm going to change this house to a home, this house to a home, as well as this one here. I'm still going to sort the students by name, but I'm going to say that they're not in a house, but rather from a home. So I've just changed the names of my variables in my grammar in English here, ultimately, to print out that, for instance, Harry is from number 4 Privet Drive, and so forth. But let's see what happens here when I run Python of this version of students.py, having changed students.csv to contain those homes and not houses. Enter. Our first value error. Like the program just doesn't work. What might explain this value error, the explanation of which rather cryptically is too many values to unpack, and the line in question is this one involving split. How did all of a sudden, after all of these successful runs of this program, did line 5 suddenly now break? Asanda?
In the line in students.csv, you have 3 values. There's a line that you have 3 values and students.
Yeah, I spent a lot of time trying to figure out where every student should be from so that we could create this problem for us. And wonderfully, like the first sentence of the book is number 4 Privet Drive. And so the fact that that address has a comma in it is problematic. Why? Because you and I decided some time ago to just standardize on commas, CSV, comma, separated values, to denote the we standardized on commas in order to delineate one value from another. And if we have commas grammatically in the student's home, we're clearly confusing it as this special symbol. And the split function is now, for just Harry, trying to split it into 3 values, not just 2. And that's why there's too many values to unpack, because we're only trying to assign 2 variables, name and house. Now, what could we do here? Well, we could just change our approach, for instance. Like, one paradigm that is not uncommon is to use something a little less common, like a vertical bar. So I could go in and change all of my commas to vertical bars. That too could eventually come back to bite us, in that if my file eventually has vertical bars somewhere, it might still break. So maybe that's not the best approach. I could maybe do something like this. I could escape the data, as I've done in the past, and maybe I could put quotes around any English string that itself contains a comma. And that's fine. I could do that, but then my code, students.py, is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes. And it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically. And so you know what? Why don't we see if there's a library in Python that exists to read and or write CSV files. Rather than reinvent a wheel, so to speak, let's see if we can write better code by standing on the shoulders of others who have come before us, programmers past, and actually use their code to do the reading and writing of CSVs, so we can focus on the part of our problem that you and I care about. So let's propose that we go back to our code here and see how we might use the CSV library. Indeed, within Python, there is a module called CSV. The documentation for it is at this URL here in Python's official documentation, but there's a few functions that are pretty readily accessible if we just dive right in. And let me propose that we do this. Let me go back to my code here, and instead of reinventing this wheel and reading the file line by line and splitting on commas and dealing now with quotes and privet drives and so forth, let's do this instead. At the start of my program, let me go up and import the CSV module. Let's use this library that someone else has written that's dealing with all of these corner cases, if you will. I'm still going to give myself a list, initially empty, in which to store all these students, but I'm going to change my approach here now just a little bit. When I open this file with width, let me go in here and change this a little bit. I'm going to go in here now and say this. Reader equals csv.reader, passing in file as input. So it turns out, if you read the documentation for the CSV module, it comes with a function called reader, whose purpose in life is to read a CSV file for you and figure out where are the commas, where are the quotes, where are all the potential corner cases, and just deal with them for you. You can override certain defaults or assumptions in case you're using not a comma, but a pipe or something else. But by default, I think it's just going to work. Now, how do I iterate over a reader and not the raw file itself? It's almost the same. The library allows you still to do this. For each row in the reader. So you're not iterating over the file directly now. You're iterating over the reader, which is, again, going to handle all of the parsing of commas and new lines and more. For each row in the reader, what am I going to do? Well, at the moment, I'm going to do this. I'm going to append to my students list the following dictionary. A dictionary that has a name whose value is the current row's first column, and whose house, or rather home now, is the row's second column. So here it's worth noting that reader isn't quite as fancy as my dictionary-based approach a moment ago, whereby, now it's worth noting that the reader isn't quite as, could I do that? Sorry, let me test one thing real fast. Name, home. Home. I will explain in just a moment. Just don't want to misspeak and disappoint. Perfect. OK. Now, it's worth noting that the reader for each line in the file indeed returns to me a row, but it returns to me a row that's a list, which is to say that the first element of that list is going to be the student's name, as before. The second element of that list is going to be the student's home, as now before. But if I want to access each of those elements, remember that lists are 0 indexed. We start counting at 0 and then 1 rather than 1 and then 2. So if I want to get at the student's name, I use row bracket 0. And if I want to get at the student's home, I use row bracket 1. But in my for loop, we can do that same unpacking as before. If I know this CSV is only going to have 2 columns, I could even do this. For name, home in reader, and now I don't need to use list notation. I can unpack things all at once and say name here and home here. The rest of my code can stay exactly the same, because what am I doing now on line 8? I'm still constructing the same dictionary as before, albeit for homes instead of houses. And I'm grabbing those values now, not from the file itself and my use of split, but the reader. And again, what the reader is going to do is figure out where are those commas, where are the quotes, and just solve that problem for you. So let me go now down to my terminal window and run Python of students.py and hit enter. And now we see successfully, sorted no less, that Draco is from Malform Manor, Harry is from number 4, comma, Privet Drive, and Ron is from the Borough. Questions now on this technique of using CSV reader from that CSV module, which again is just getting us out of the business of reading each line ourselves and reading each of those commas and splitting. Piyush?
Hi there. So my questions are related to something a bit in the past. I recognize that you are reading a file every time we're assuming that we have the CSV file to hand already in this case. Is it possible to make a file readable and writable? So in case if you want, you could write some stuff to the file, but then at the same time you could have another function that reads through the file and does changes to it as you go along.
A really good question, and the short answer is yes. However, historically, the mental model for a file is that of a cassette tape. Years ago, not really in use anymore, but cassette tapes are sequential, whereby they start at the beginning, and if you want to get to the end, you kind of have to unwind the tape to get to that point. The closest analog nowadays would be something like Netflix or any streaming service where there's a scrubber that you have to go left to right. You can't just jump there or jump there. You don't have random access. So the problem with files, if you want to read and write them, you or some library needs to keep track of where you are in the file, so that if you're reading from the top and then you write at the bottom and you want to start reading again, you seek back to the beginning. So it's not something we'll do here in class. It's more involved, but it's absolutely doable. For our purposes, we'll generally recommend read the file, and then if you want to change it, write it back out rather than trying to make more piecemeal changes, which is good if, though, the file is massive and it would just be very expensive time-wise to change the whole thing. Other questions on this CSV reader? Over to Dogaba, if I'm saying it right.
Yeah, exactly. It's possible to write a paragraph in that file.
Absolutely. Right now I'm writing very small strings, just names or houses as I did before, but you can absolutely write as much text as you want. Indeed. Other questions on CSV reader? Maria?
Yes, can a user choose himself a key, like input key will be a name or home? Not the program will be...
So short answer, yes, we could absolutely write a program that prompts the user for a name and a home, and we could write out those values. And in a moment, we'll see how you can write to a CSV file. For now, I'm assuming as the programmer who created students.csv that I know what the columns are going to be, and therefore I'm naming my variables accordingly. However, this is a good segue to one final feature of reading CSVs, which is that you don't have to rely on either getting a row as a list and using bracket 0 or bracket 1, and you don't have to unpack things manually in this way, we could actually be smarter and start storing the names of these columns in the CSV file itself. And in fact, if any of you have ever opened a spreadsheet file before, be it in Excel, Apple Numbers, Google Spreadsheets, or the like, odds are you've noticed that the first row very frequently is a little different. It actually is boldface sometimes, or it actually contains the names of those columns, the names of those attributes below. And we can do this here in students.csv. I don't have to just keep assuming that the student's name is first and that the student's home is second. I can explicitly bake that information into the file just to reduce the probability of mistakes down the road. I can literally use the first row of this file and say name, comma, home. So notice that name is not literally someone's name, and home is not literally someone's home. It is literally the words name and home separated by a comma. And if I now go back into students.py and don't use CSV Reader, but instead I use a dictionary reader, I can actually treat my CSV file even more flexibly, not just for this, but for other examples too. Let me do this. Instead of using a CSV reader, let me use a CSV dict reader, which will now iterate over the file, top to bottom, loading in each line of text not as a list of columns, but as a dictionary of columns. What's nice about this is that it's going to give me automatic access now to those columns' names. I'm going to revert to just saying for row in reader. And now I'm going to append a name and a home. But how am I going to get access to the current row's name and the current row's home? Well, earlier I used bracket 0 for the first and bracket 1 for the second when I was using a reader. A reader returns lists. A dict reader or dictionary reader returns dictionaries, one at a time. And so if I want to access the current row's name, I can say row quote unquote name. I can say here for home, row quote unquote home, and I now have access to those same values. The only change I had to make, to be clear, was in my CSV file, I had to include on the very first row little hints as to what these columns are. And if I now run this code, I think it should behave pretty much the same, Python of students.py, and indeed, we get the same sentences, but now my code is more robust against changes in this data. If I were to open this CSV file in Excel or Google Spreadsheets or Apple Numbers and for whatever reason change the columns around, maybe this is a file that you're sharing with someone else, and just because they decide to sort things differently left to right by moving the columns around, previously my code would have broken because I was assuming that name is always first and home is always second. But if I did this, be it manually in one of those programs or here, home comma name, and suppose I reversed all of this. The home comes first, followed by Harry. The borough, then by Ron. And then lastly, Malfoy Manor, then Draco. Notice that my file is now completely flipped. The first column's now the second, and the second's the first, but I took care to update the header of that file, the first row. Notice my Python code, I'm not going to touch it at all. I'm going to rerun Python of students.py and hit enter, and it still just works. And this too is an example of like coding defensively. Like what if someone changes your CSV file, your data file? Ideally that won't happen, but even if it does now, because I'm using a dictionary reader that's going to infer from that first row for me what the columns are called, my code just keeps working. And so it keeps getting, if you will, better and better. Any questions now on this approach? Or anything else with CSVs? Yeah, Nelly?
What is important of new line in CSV file?
What about the new line in the CSV file?
Yeah, what is the importance of new line in CSV file?
What's the importance of the new line in the CSV file? It's partly a convention. In the world of text files, we humans have just been for decades in the habit of storing data line by line. It's visually convenient. It's just easy to extract from the file because you just look for the new lines. So the new line just separates some data from some other data. We could use any other symbol on the keyboard, but it's just common to hit enter to just move the data to the next line. Just a convention. Other questions from KB?
Thank you.
Sure.
So it seems to be working fine if you just have name and home. I'm wondering what will happen if you want to put in more data Say you wanted to add a house to both the name and the home.
Sure, if you wanted to add the house back. So if I go in here and add house last, and I go here and say Gryffindor for Harry, Gryffindor for Ron, and Slytherin for Draco. Now I have 3 columns, effectively, if you will. Home on the left, name in the middle, house on the right, each separated by commas with weird things like number 4, comma, privet drive, still quoted. Notice if I go back to students.py and I don't change the code at all and run Python of students.py, it still just works. And this is what's so powerful about a dictionary reader. It can change over time. It can have more and more columns. Your existing code is not going to break. Your code would break, would be much more fragile, so to speak, if you were making assumptions like the first column's always going to be name. The second column's always going to be house. Things will break fast if those assumptions break down. So not a problem in this case. Well, let me propose that besides reading CSVs, let's at least take a peek at how we might write a CSV too. If you're writing a program in which you want to store not just students' names, but maybe their homes as well in a file, how can we keep adding to this file? Well, let me go ahead and propose that we do this. Let me go ahead and remove students.csv so that it no longer exists, and we'll recreate it now programmatically in code. I'm going to go ahead and open up students.py, and in students.py, let's go ahead and still import CSV at the top. Let's go ahead now and prompt the user for 2 things, a name of a student and the home of the same. So name equals input, quote unquote, what's your name, question mark. And then this one, home equals input, quote unquote, where's your home. So now the file doesn't yet exist. We're going to create it programmatically in code. With open, quote unquote, students.csv, but this time I'm going to open it in append mode. I erase the file, so it doesn't yet exist. Append will automatically create it if need be, but it's not going to change it again and again. It's going to keep appending to it. It won't overwrite. So once I have this file open as a variable called file, let's do this. I need a different feature of the CSV module called a dictionary writer. So I'm going to do this. Writer equals csv.dictWriter. And this is just a feature of the library that gives you the ability to write to a CSV file. And I'm going to pass in as input 2 things, not just one. I'm going to pass in the file itself so that it knows where to write these these comma-separated values to. And I'm going to pass in a named parameter called field names. And you only know about this from the documentation alone, or this example here. The field names I want to write to this file are going to be, respectively, name and home. I'm going to go with just 2 left to right. What do I want to do now that I've created that dictionary writer? Well, let me call a function that comes with the writer, a method called writeRow, and it takes as input a dictionary. And that's why this is a dict writer and not just a writer alone that takes lists. A dictionary writer takes a dictionary for each row, a collection of key value pairs that you want this library to put in the right columns. So what do I want to write? I'm going to write a dictionary using my curly braces, as always, whose name is whatever the student's name is in that variable from earlier, and whose home is whatever the value of that home variable is from earlier. So again, I'm not going to bother printing out any commas. I'm not going to print out any new lines. I'm going to let the dictWriter function handle all of that for me. So that's it. I don't even need to close the file because once you're at the end of a with, it will just close automatically. So let me go ahead and run Python of students.py and hit enter. All right, what's your name? Let's go ahead and start with Harry. Enter. Where's your home? Number 4, comma, privet drive, which could potentially break things, but I think the library will be smart. Enter. And nothing bad seems to happen, which is generally a good thing. Let's open students.csv and see what the new version looks like. It looks like, as hoped, that module, the CSV module, handled the comma and handled the quoting for me. Let's try one other student. Let's go back to students.py. Let's go ahead and run Python of students.py. What's your name? Ron. The borough. Enter. OK, no errors. That's good. Let's go back to students.csv. And there's Ron and the borough. Let's try one more. And I'll leave the CSV open. Python of students.py. Enter. What's your name? Draco. And lives in Malfoy Manor. Enter. And watch the CSV file at the top of the screen. There it is. He appears at the top. So that's how we might edit this file using a dictionary writer, which allows us to automate this process of creating that file, not needing to do it from scratch. Any questions now on writing or reading CSVs? Harris, over to you.
Hello, David, and this is Harris from New Zealand.
Hello.
I only have one question. Is there any specific situation for me to use single quotation or double quotation? Because after the print, we use single quotation to represent the key of the dictionary. But after the reading or writing, we use the double quotation.
It's a good question. In Python, you can generally use double quotes or you can use single quotes, and it doesn't matter. You should just be self-consistent so that stylistically your code looks the same all throughout. Sometimes, though, it is necessary to alternate if you're already using double quotes, as I was earlier for a long F string. But inside that F string, I was interpolating the values of some variables using curly braces, and those variables were dictionaries. And in order to index into a dictionary, you use square brackets and then quotes. But if you're already using double quotes out here, you should generally use single quotes here or vice versa. But otherwise, I'm in the habit of using double quotes everywhere. Others are in the habit of using single quotes everywhere. It only matters sometimes if one might be confused for the other. Other questions on dictionary writing or reading? Matali, if I'm saying it right?
Yeah, David. My question is, can we use multiple CSV files in any program?
Absolutely. You can use as many CSV files as you want, and it's just one of the formats that you can use to save data. Other questions on CSVs or file I/O? Yeah, Michael?
Yeah, thanks for taking my question. So when you're reading from the file, you had the as a dictionary, you had the fields called. Couldn't you just call when you're reading? Couldn't you just call the row?
Could you just call them?
In the previous version of the students .py file, when you're reading each row, you were splitting out the fields by name. Couldn't you? Yeah. So when you're appending to the students list, can you just call for row in reader students.append row rather than naming each of the fields?
Oh, very clever. Short answer, yes. Insofar as dict reader returns one dictionary at a time, when you loop over it, row is already going to be a dictionary. So yes, you could actually get away with doing this, and the effect would really be the same in this case. Good observation. How about one more question on CSVs? Yeah, Joachim?
Yeah, when reading in CSVs from my past work with data, a lot of things can go wrong. I don't know if it's a fair question that you can answer in a few sentences, but are there any best practices to double check that sort of no mistakes occurred?
It's a really good question. And I would say in general, if you're using code to generate the CSVs and to read the CSVs, and you're using a good library, theoretically, nothing should go wrong. It should be 100% correct if the libraries are 100% correct. You and I tend to be the problem. Like when you let a human touch the CSV, or when Excel or Apple Numbers or some other tools involved that might not be aligned with your code's expectations, things then, yes, can break. The goal really, sometimes, honestly, the solution is manual fixes. You go in and fix the CSV, or you have a lot of error checking, or you have a lot of try except just to tolerate mistakes in the data. But generally, I would say if you're using CSV or any file format internally to a program to both read and write it, you shouldn't have concerns there. You and I, the humans, are the problem, generally speaking, and not the programmers, the users of those files instead. Well, allow me to propose that we pivot ultimately from CSVs to one other type of file. Indeed, actually, let me fix this so this is not on the screen. Let me reset, sorry. All right, allow me to propose that we leave CSVs behind, but to note that they're not the only file format you can use in order to read or write data. In fact, they're a popular format, as is just raw text files, .txt files, but you can store data really any way that you want. We've just picked CSVs because it's representative of how you might read and write from a file, and do so in a structured way, where you can somehow have multiple keys, multiple values, all in the same file, without having to resort to what would be otherwise known as a binary file. So a binary file is a file that's really just zeros and ones, and they can be laid out in any pattern you might want, particularly if you want to store not textual information, but maybe graphical or audio or video information as well. So it turns out that Python is really good when it comes to having libraries for really everything. And in fact, there's a popular library called Pillow that allows you to navigate image files as well, and to perform operations on image files. You can apply filters a la Instagram. You can animate them as well. And so what I thought we'd do is leave behind text files for now and tackle one more demonstration, this time focusing on this particular library and image files instead. So let me propose that we go over here to VS Code and create a program ultimately that creates an animated GIF. These things are everywhere nowadays in the form of memes and animations and stickers and the like. And an animated GIF is really just an image file that has multiple images inside of it. And your computer or your phone shows you those images one after another, sometimes on an endless loop, again and again. And so long as there's enough images, it creates the illusion of animation, because your mind and mine kind of fills in the gaps visually and just assumes that if something is moving, even though you're only seeing 1 frame per second or some sequence thereof, it looks like an animation. So it's like a simplistic version of a video file. Well, let me propose that we start with maybe a couple of costumes from another popular programming language. And let me go ahead and open up my first costume here, number 1. So suppose here that this is a costume, or really just a static image here, costume1.gif. And it's just a static picture of a cat, no movement at all. Let me go ahead now and open up a second one, costume2.gif, that looks a little bit different. Notice, and I'll go back and forth, this cat's legs are a little bit aligned differently, so that this was version 1. And this was version 2. Now, these cats come from a programming language from MIT called Scratch that allows you very graphically to animate all this and more. But we'll use just these 2 static images, costume 1 and costume 2, to create our own animated GIF that after this you could text to a friend or message them, much like any meme online. Well, let me propose that we create this animated GIF, not by just using some off-the-shelf program that we downloaded, but by writing our own code. I'm going to go ahead and create a new file here with code called costumes.py, whose purpose in life is going to be to, whoops, spoiler, sorry. Sorry. Well, you'll see how that's about what we're about to do. Let me go ahead and run code of costumes.py and create our very own program that's going to take as input 2 or even more image files, and then generate an animated GIF from them by essentially creating this animated GIF by toggling back and forth endlessly between those 2 images. Well, how am I going to do this? Well, let's assume that this will be a program called costumes.py that expects 2 command line arguments, the names of the files, the individual costumes that we want to animate back and forth. So to do that, I'm going to import sys so that we ultimately have access to sys.argv. I'm then, from this Pillow library, going to import support for images specifically. So from PIL, import image, capital I, as per the library's documentation. Now I'm going to give myself an empty list called images, just so I have a list in which to store 1 or 2 or more of these images. And now let me do this. For each argument in sys.argv, I'm going to go ahead and create a new image variable, set it equal to this image dot open function passing in arg. Now, what is this doing? I'm proposing that eventually I want to be able to run Python of costumes.py, and then as command line arguments specify costume1.gif space costume2.gif. So I want to take in those file names from the command line as my arguments. So what am I doing here? Well, I'm iterating over sys.argv, all of the words in my command line arguments. I'm creating a variable called image, and I'm passing to this function image.open from the Pillow library that specific argument. And that library is essentially going to open that image in a way that gives me a lot of functionality for manipulating it, like animating. Now I'm going to go ahead and append to my images list that particular image. And that's it. So this loop's purpose in life is just to iterate over the command line arguments and open those images using this library. The last line is pretty straightforward. I'm going to say this. I'm going to grab the first of those images, which is going to be in my list at location 0, and I'm going to save it to disk. That is, I'm going to save this file. Now, in the past, when we use CSVs or text files, I had to do the file opening. I had to do the file writing, maybe even the closing. I don't need to do that with this library. The Pillow library takes care of the opening, the closing, and the saving for me by just calling save. I'm going to call this save function, and just to leave space, because I have a number of arguments to pass, I'm going to move to another line so it fits. I'm going to pass in the name of the file that I want to create, costume.gif. That will be the name of my animated GIF. I'm going to tell this library to save all of the frames that I pass to it. So the first costume, the second costume, and even more if I gave them. I'm going to then append to this first image, the image is 0, the following images. Equals this list of images. And this is a bit clever, but I'm going to do this. I want to append the next image there, images 1. And now I want to specify a duration of 200 milliseconds for each of these frames, and I want this to loop forever. And if you specify loop equals 0, that is time 0, it means it's just not going to loop a finite number of times, but an infinite number of times instead. And I need to do one other thing. Recall that sys.argv contains not just the words I typed after my program's name, but what else does sys.argv contain? If you think back to our discussion of command line arguments, what else is in sys.argv besides the words I'm about to type, like costume1.gif and costume2? How about Mackenzie, your thoughts?
Yeah, hi, can you hear me?
Yes, we can.
Yeah, so we'll actually get in the original name of the program we want to run.
Indeed.
The costumes.py.
Indeed, we'll get the original name of the program, costumes.py in this case, which is not a GIF, obviously. So remember that using slices in Python, we can do this. If sys.argv is a list, and we want to get a slice of that list, everything after the first element, we can do 1:, which says start at location 1, not 0, and take a slice all the way to the end. So give me everything except the first thing in that list, which, to Mackenzie's point, is the name of the program. Now, if I haven't made any mistakes, let's see what happens. I'm going to run Python of costumes.py. I'm going to, whoops, sorry. I'm going to run Python of costumes.py. There we go. Whew. I'm going to run Python of costumes.py, and now I'm going to specify the two images that I want to animate. So costume1.gif and costume2.gif. What is the code now going to do? Well, to recap, we're using the sys library to access those command line arguments. We're using the Pillow library to treat those files as images, and with all the functionality that comes with that library. I'm using this images list just to accumulate all of these images one at a time from the command line. And in lines 7 through 9, I'm just using a loop to iterate over all of them and just add them to this list after opening them with the library. And the last step, which is really just one line of code broken onto 3 so that it all fits, I'm going to save the first image, but I'm asking the library to append this other image to it as well. Not bracket 0, but bracket 1. And if I had more, I could express those as well. I want to save all of these files together. I want to pause 200 milliseconds, a fifth of a second, in between each frame. And I want it to loop infinitely many times. So now, if I cross my fingers as always, hit Enter, nothing bad happened, and that's almost always a good thing. Let me now run code of costumes.gif to open up in VS Code the final image. And what I think I should see is a very happy cat. And indeed. So now we've seen not only that we can read and write files, be it textually, we can read and now write files that are binary, 0s and 1s. We've just scratched the surface. This is using the library called Pillow. But ultimately, this is going to give us the ability to read and write files however we want. So in order to use this technique in your programs, it'll amount to using functions like open in libraries. And we can't wait to see what you achieve with them next. All right, that's it for this week. We will see you next time. All right. Are we live again? Okay, we are officially a wrap for today, but wanted to leave a couple minutes for questions if folks have them before we drop off here. Thank you again for joining us. It's such a fun time to gather each week to actually do this, even though we're learning to program, but somehow hopefully it's all fun. Questions from the group here. Roderick, over to you.
Hi, David. So my question is, in Python, aren't we required to actually explicitly write the path of those file? Let's say, for example, for the custom.gif, aren't we required to actually write the path to access those file? Or Python actually reads it on its own by importing some of those libraries?
It's not the latter. It's something in between what you proposed. So when you don't specify the path, Python and a lot of languages just look in the current directory. So whatever folder your Python file is in, the program will assume that your GIFs are in as well. So if these files were elsewhere, for instance, in a subfolder, I might have needed to do something like this, folder/costume.gif, folder/costume2.gif. You might have to specify, but I have very deliberately put them all in my same folder just to make my life easier for now. Good question. Others from the group. Yashvi?
Oh, yeah. First of all, thank you for today's lecture. It was very much fun. And my question was that how can we introduce costume.gif in our code space?
Oh, these files. So if you go to, if Carter, you don't mind, take a look at the chat, Yashvi, and we'll paste the URL of today's code. And I included the GIFs, costume 1 and 2, in the folder for today so that you can create the same. Other questions? Rajul, if I'm saying it right?
Yes. So my question was related generally to computer science.
Okay.
So if I want to go inside, like in the field of AI and ML, and I have taken CS50 and CS50 Python, this one. So what should I take next?
So if you really like AI, a colleague of ours teaches an AI course with Python. If Carter, you wouldn't mind pasting that one too. Keep an eye on the chat in a moment, Rajul, and I might suggest that one next. Oh, sorry, Rungshin, can we unmute? Yeah.
Yes, I have another question. It was related to someone asked a question yesterday. Like he asked that if Python will be used to develop apps, and you said only Java would be used, not too much of Python. So if the app uses machine learning, so will Python play a role there, or Java could do that stuff?
Oh, you can absolutely do machine learning stuff with Java, but if you're thinking about an app in like the mobile device sense, like a tablet or a phone, a lot of the machine learning stuff is probably done server side anyway. So you could write Python code on a server that the app talks to over the internet, and then you could use any Python libraries that might be popular that you might want to use as well. When I said that Python, generally speaking, it's for Android, it's Java and Kotlin, and for iOS, it's Swift and Objective-C that are typically used for apps.
Okay, thank you.
Sure. I think we have time for one more question, if that's OK. Then we have to drop off here in Cambridge. Over to, how about Dogaba, if you can hear me?
Yes.
Yes.
For sure. So I would like to ask about the GIF custom. Could we have more extra stickers to try to animate?
Oh, interesting. We weren't planning on that. If you post in one, if you email me after class, my email address should be on the course's website, we can point you at some others. What I did to grab those costumes was I used Scratch, which has a web page, and I just exported the images in order to get the frames to use them for this. And we can point you at that.
And also, I have one question. Can we add HTML and Python together to make something fun, like animation work?
Short answer, yes. You could do it for animation. It's often Python used for web programming more generally. If Carter, you wouldn't mind pasting the link of another class, a colleague of ours teaches one on Python and web stuff. You might like that as well.
Thank you.
Sure, and I hope you'll forgive that we need to drop off here in Cambridge, but we'll be in touch via email about the next class. Thank you all so much again for spending time with us and for tolerating all of my mistakes. You'll see the new and improved version online ultimately, but see you all online soon. Thank you.